Hello everyone, welcome to Byju's Exam Prep IAS. A very good morning to all of you. First and foremost, just the confirmation from you if audio and video both are working fine. All right, great. So let's begin with our session. So yesterday we had completed our chapter of biotechnology, and today there are three small chapters that we have to discuss. One, nanotechnology, and second, you can say a part of the same part, which is robotics and artificial intelligence. So these are the things that we are going to cover in today's class. Now, first and foremost, to start with nanotechnology. Now, when it comes to nanotechnology, first and foremost, from the perspective of your examination, at prelims level, this is a subject that I would consider more important. At mains level, not so much. When you look at the past papers, you'll see that a lot of questions have come in the past papers, and especially last 5 6 odd years, we have seen that the number of questions from this part has started to increase, that now they have shown more interest in asking questions from nanotechnology. And that's why we see that, i mean 2015 onwards, I would say, you'll see that almost every year they have asked a question. So that's why this has started to become an important topic, although not a very big chapter. It's a very limited, it has a very limited scope, because it very quickly goes to a level of engineering which is very advanced. So that's why we don't go to that level, but the basics are where the questions are being asked from, and that is what is expected of you. Yes, questions can also come in the mains examination, and there have been a couple of questions in the past in the mains as well, but the questions have been fairly simple. And we'll also discuss some of the areas from where there's a potential that they could ask a question in your mains examination. So, to begin with, first of all, when we say nanotechnology, again, trying to break down the word to understand the meaning of this particular topic, we have nano and technology. So, nano, the literal meaning of the word nano is dwarf. So that's why you'll see that anything that is very small, we associate the word nano with it. We discussed about nano satellites. The satellites which have a weight of just 1 to 25 kg, we call them as nano satellites. Similarly, there is Tata Nano. So Tata Nano, the compact car of India. So that's why the term nano has been used there as well, because this is a small uh, compact car. So that's why the term nano, you will often see that nano is associated with anything that is small, because the literal meaning of the term nano is dwarf. All right. So nano basically means dwarf. But in the context of nanotechnology that we are discussing here, we are talking about the scale of 1 nanometer. How much is 1 nanometer? What's this scale of 1 nanometer in terms of meter? Yes, 10 to the power of minus 9 meters, right? So this is 10 to the power of minus 9 meters. So 1 nanometer is 10 to the power of minus 9 meters. So when we are talking about nanotechnology, we are talking about the scale of 10 to the power of minus 9 meters or thereabouts. 1 nanometer, 10 nanometers, 100 nanometers, zero point 0.1 nanometers. So this entire range, this scale is called as nanoscale. Now, what is so important about this particular scale that we have named an entire subject only around this 1 nanometer? Why is there no millimeter technology, or let's say milli technology or micro technology and so on? Why nanotechnology only has become so important, and why exactly are we seeing it in a very different context? To understand that, just see what happens at nanoscale. Nanoscale is the scale where molecules are formed. We discussed about atoms, we discussed about what lies inside the atom. We discussed that there are electrons, and then there is a nucleus, and inside the nucleus you have protons and neutrons. So these are the things that we discussed. But at an atom level, what we see is that any atom on its own cannot exist. Atoms always exist as molecules, as a bunch of atoms clubbed together. Maybe just two atoms together, maybe four atoms together, maybe combining with another atom of another element. But we always see that they exist as molecules. So, molecules, when it comes to matter and the different types of matter that we see around us, atoms, just remember this, that atoms cannot exist independently, they always exist as molecules. So that's why the scale of molecule is very important, because this is where the atoms start to gain their specific properties of matter. What you see around you and what properties you see, whether it is, let's say, something made of a metal, something made of a non-metal, something made of wood, something made of plastic, whatever properties you know about each and everything around you, all these properties, they start to show up at this nanoscale. So that's why this nanoscale of 1 nanometer to, let's say, 100 nanometers, this is a scale that becomes very crucial, even 0.1 nanometers. So that's why anything around 1 nanometer scale. So we see that everything starts to gain their properties at this particular point. Just to give you an example, we have hydrogen and we have oxygen, correct? And you know that when oxygen and hydrogen combine, they can form water, right? But there's another molecule that they can form, H2O2, called as hydrogen peroxide. Now, this hydrogen peroxide and water, the only difference that we have between these two molecules is that hydrogen peroxide has one extra oxygen. That's it, only one extra oxygen. But this one extra oxygen completely changes the properties of hydrogen peroxide. Hydrogen peroxide can be used as an oxidizer, it can be used as an antiseptic, it is used in medical field, it is also used as a chemical reagent in, in some of the industries. So there are many ways in which hydrogen peroxide is used. Highly reactive chemical, all right, hydrogen peroxide, just with one extra oxygen. Whereas when it comes to water, I need not tell you the properties of water and where we use water, but we know that water is the essence of life for us, correct? So, and hydrogen peroxide is not, you can't drink, don't even try at home uh, drinking hydrogen peroxide, uh, not at all, please. So that's why on one hand you have H2O, which is kind of basis of life for every one of us, and on the other hand you have H2O2, that is hydrogen peroxide, which has to be avoided, which is used as an antiseptic, can be used in uh, various industries. So what is the basic difference between the two? The only difference is one extra oxygen. So this is the nanoscale. That beneath this, you had the atom scale where hydrogen and oxygen had their own properties, but they can't exist as an atom. They would always combine together and exist as a molecule. Forget about two different elements combining. Just consider carbon. Just consider carbon. Now, in case of carbon, it's not even, let's say, even if it is not combining with anything, we know that carbon can exist as graphite, carbon can exist as diamond, and the same carbon, we, if you remember, we also discussed that even coal is nothing but carbon, just mixed with some impurities, but coal otherwise is essentially carbon. Now graphite, diamond and coal, all of these are just carbon, but having completely different opposite or completely different properties altogether, right? Coal, we discussed that coal is used as a fuel, you can use it, the combustion of coal can produce energy for you. Diamond, you cannot simply diamond will not catch fire that easily. Diamond is one of the strongest natural substances that we know of, and that's why it becomes a precious element for us, that's why it becomes a precious stone, and it's one a very costly jewelry for us, right? Diamond. Graphite, on the other hand, you are using it in your pencils. So all of these are nothing but carbon, just that the arrangement of carbon is different. Arrangement of carbon in graphite is completely different as compared to the arrangement of carbon in diamond, that's completely different from the arrangement of carbon in coal. So although all of these are nothing but carbon and carbon only, just that structurally they are different, and this difference in structure is something that actually brings in all these different properties. So that is what is at the nanoscale. So in all these forms and all these different forms, they are also called as allotropes of carbon. They are also called as allotropes of carbon. The different forms where structurally they are different, it's called as allotropes of carbon. So that's why we see that just that these small changes in the properties, just because of small changes in the structure, the properties are completely different. This is nanoscale. All these properties for the first time, they start to show at the nanoscale. Now, until now, we are just talking about these properties, that fine, these properties start showing at the nanoscale, and this is what we do, and this is what we have found. But when it comes to nanotechnology, it has been a fairly new science. It's a science that has just developed, you can say, in the last 3-4 decades only. Until 1974, the name nanotechnology itself did not exist. So forget about the advancements in nanotechnology. Even the name did not exist until 1974. And even if, let's say, in 1974 the term nanotechnology was coined, we did not have anything to study about nanotechnology. Theoretically we could do a lot of studies, but practically we had nothing that we can work on. And that changes a little later. So that's why we see that nanotechnology is a very new science. And whatever we have been doing until now with nanotechnology, whatever we know about nanotechnology, we still believe is nothing compared to what nanotechnology can also actually do. Let me just give you a small example of how you can manipulate the properties and change the properties at the nanoscale and bring in a completely different material altogether. So for example, let's say if I give you two surfaces, let's say this is one surface, and suppose that this is another surface. All right. And suppose that I am putting them on a flame. All right. Just consider this as a flame. And let's say that heat is being supplied to this. Let's say this is called as A and this is called as B. So if I ask you out of A and B, which of the above will have a lower boiling point, or let's say lower melting point? Which of the two surfaces would have a lower melting point? Would it be A or would it be B? I'm launching the poll. I'll just give you 10 seconds for it. Which will have a lower melting point? A will have a melting point lower, or a B will have a lower melting point if they are made of the same material? So we have almost a 50-50 case. 51% of you have marked A having the lower melting point, and 49% of you have marked B having the lower melting point. Now, tell me the reason. Tell me the reason why did you mark A or why did you mark B? Alok, your answer is correct. Abhishek, your answer is correct. Monica, correct. Masira, correct. Narendra, correct. Yeah. So many of you have given correct answers. All right. For those of you who have actually given the correct explanation but the wrong answer, I'll tell you why. So see what's happening here. Between A and B, the difference is the surface area that they are presenting to the flame, right? The surface area that they are presenting to the flame. A is presenting lesser surface area as compared to B. So what happens at A is that all the heat is concentrated at one point. All the heat is concentrated at one point. So that's why it will accumulate heat much faster and it will start to melt easily. Whereas in case of B, first the heat will be distributed all across the surface. First the heat will be distributed all across the surface, and then after some time it will start to melt. So that's why you have to provide more heat, because there will be a heat distribution that will happen in B. Whereas in case of A, the heat distribution will not happen. All the heat will be concentrated at one particular point. So that is the reason why between A and B, A will have a lower melting point. A will have a lower melting point. A will melt first and then B will start melting. All right. So many of you actually gave the correct explanation, but then you thought that it should be B because of that. No, A is the correct answer. So in this particular case, now just imagine that if there was a possibility for me to manipulate the surfaces at nanoscale, then what happens? I could increase the surface area of A, right? I could flatten this surface out. I could flatten this surface out, and by doing that, I can increase the melting point of A. So for me, with the help of nanotechnology, it is possible to even change the melting point. So similarly, what happens is that uh, a lot of properties can be manipulated, a lot of properties can be enhanced, and all these things would be made possible with the help of nanotechnology. Some of these areas we see that already they are in work. There are some of the key areas where we already have succeeded, but it's a long way to go. It's just the start. Although we are 30 years almost into the researches related to nanotechnology, but we still understand that whatever we have done, whatever we have achieved, is still not more than 10 to 20% of what nanotechnology is actually capable of. So that's why nanotechnology is one of those technologies of the future. Although in if you're watching films, then it is something which is already there. For example, iron man suit, it talks about nanotechnology and how nanotechnology has been used to make the Iron Man suit. So until now, possible in movies, in the future possible in real time as well, so real life as well. So that's why all these things will happen, and nanotechnology will take its effect in a manner that right now is more of science fiction and movie based. But yeah, some of you have mentioned even in case of Ant-Man. So in case of Ant-Man, I'll discuss one topic here which is related to what they show in Ant-Man. So all these films that we have seen, and we have seen that they have been very casually mentioning that nanotechnology has been used and carbon nanotubes have been used and this and that, all these things they have mentioned in the movies. But yes, this is a future possibility. A lot of this which has been made possible in the films will be a future possibility in real life as well. So there are a lot of things where we'll discuss about a lot of applications where already we are using nanotechnology, whether in food industry, whether in agriculture, whether in healthcare, whether in defense, whether in electronics. There are so many ways in which we are already using nanotechnology. But yet I am saying that whatever, everything already done, everything that whatever we have already achieved, yet we haven't achieved more than 10-20% of what nanotechnology is actually capable of. So that's why there will be a lot of things in the future where we'll see that nanotechnology will take a completely different effect. So comes from a Latin word for dwarf, as I mentioned. Now, in particular term, when it comes to nanotechnology, the term nanotechnology was coined by a Japanese scientist, Norio Taniguchi. He was the one in 1974. He was the one who mentioned the term nanotechnology for the first time. He started using, and you can say in a manner this branch now started to take a shape because of the nomenclature now that was used for this. So that is how we see that nanotechnology comes into effect. And when we define nanotechnology, this is how we can define. So if you go to the website of Ministry of Science and Technology, this is how they define nanotechnology. They say that this is nanotechnology is processing of separation and consolidation and deformation of material by one atom or by one molecule at a level of 1 to 100 nanometers in size. So that's why we are talking about a branch of science that deals with minute particles in the range of 1 to 100 nanometers. Typically 1 to 100 nanometers, but not always correct, because even something which is at 0.1 nanometer scale or near about, even that we take as nanoscale. So that's why anything in this particular range will be called as nanotechnology, or any material at this level will be called as nanomaterial. The science related to it will be called as nanoscience, and so on. So this is a brief about this nanotechnology. When we look at the particles, this range basically can be called as nano range, and all these materials can be called as nanomaterials. So that's why if you see, even compared to our red blood cells or compared to a virus, size of a virus, these are particles which are even smaller than that. That almost you can see 1000 times smaller in size as compared to even a virus. So that's why we see that nanoparticles, nano materials will be useful in a lot of ways. For example, let's say we want to send a medicine to a certain part of the body. We can do that with the help of nanomaterials, because these nanomaterials, they are 1000 times smaller than the red blood cells. So very easily inside our body they can travel from one place to another through the red blood cells. So we can inject the nano particles with the medicine inside the bloodstream, and they could be carried to the required location. So in this manner we understand that this becomes useful because they are so small in size. That is the reason why we are able to use nanotechnology. So overall what we see is that our understanding of nanotechnology, as I told you, just started to begin in the 1970s more. But before that, we see one of the ways, one of the early, you can say, the setups that we have for nanotechnology begins in 1959. And in 1959, we had a very famous American scientist, Richard Feynman. Now, Richard Feynman, he was giving a lecture in a seminar about quantum mechanics, about quantum physics. And this is where, for the first time, he mentioned something that also generated a lot of interest in the minds of the students and the faculty alike. He said, there's plenty of room at the bottom. Now, this one statement, plenty of room at the bottom, became very famous. I mean, you go on Google and you'll see that there are so many things that have been done on this one particular line. But this one line that he spoke of there, he basically tried to mention that until now, most of the scientists are basically looking at a surface level. They are looking at what they can see. They have not tried to look beneath. They have not tried to look at the atomic scale, or at the scale of the molecule, because if you go to that scale, you'll see that it's a completely different world. And in America, nanotechnology or quantum mechanics had not been taken very seriously until then. It was just starting to develop. In Europe, it had developed much faster, much earlier, but in America, it was just developing. So Richard Feynman was a very, very famous scientist, has been one of the most famous scientists of, you can say, this generation of the last 50 odd years. And that's why, I mean, not only was he a brilliant scientist, but at the same time, he was a very popular name as well. And so much so that even the biography that has been published about his life, it has been one of the best sellers in the world. There's a book called as Surely You Are Joking, Mr. Finman. So Surely You Are Joking, Mr. Finman became one of the highest selling biographies. Now just imagine that a scientist, and that too a quantum mechanics based scientist's biography, becomes a highest selling novel of, I mean, highest selling book in the world. So that's why this is something, this is very unique for a scientist. But because he was very famous in that sense, has been very popular name. And why the name of the book is so, that Surely You Are Joking, Mr. Finman. If you read the book, you'll understand that, for example, he made his own radio when his mother did not let him listen to radio, and asked him to just go and study. What happens with all of us in childhood. So something similar happened to him also, that he was just asked to leave the radio and just go and study. And he went there in his room, and somehow he was able to make something that could catch the nearest station. And he was, I think, 10, 11 years old when he did that. So that's why he became, because of these kind of stories associated with his life, he became a very popular figure. And that's why whatever he used to say, it had a lot of meaning. uh, and he was a scientist also associated with the atomic program of America as well. If you have seen, there is a film that just came recently, Oppenheimer. Oppenheimer, who was the one who took over the atomic program of US, and he was the one, under him the atom bomb was made by US. So in his team, Richard Feynman also was one of the people who used to work in his team. Anyone who has seen the film Oppenheimer, became a very famous film in the last month or so since its release. And some of you have seen it. So if you, I mean, if you have seen it, if you remember, at the time of the nuclear explosion test, there is one person sitting in the car, and there is one person sitting beside him who has applied the sunscreen. So that person sitting in the car they have shown is Richard Feynman. All right. So anyway, let's let's move away from the movies. So 1959, you see that one of the ways the setup is made. All right, the setup is made, and this setup leads to a lot of theoretical research that starts in the field of nanotechnology. Yet it is not being seen as nanotechnology, it is being seen as a research happening in quantum mechanics. And then in 1974, we see that there is a name that is given to this branch, and now all the studies, all the research and development, it starts to happen inside the scope of nanotechnology now. And then after that, in 1981 a major breakthrough happens, that there is an invention, and this invention is a microscope that could see at nanoscale. Until now it was a theoretical study, because any microscope that we had, the microscopes did not have the capacity to see nanomaterials. But in 1981 there is this scanning tunneling microscope that is invented. And with the invention of scanning tunneling microscope, we see that this is where nanotechnology starts to take a shape, because now with the help of this microscope it is possible for us to look at nanoscale, to see nanomaterials, to analyze nanomaterial. It becomes possible for us. So what is this scanning tunneling microscope? It's a very different microscope, based on a very different concept compared to normal microscopes, which are largely optical microscopes, which just rely on the visible light to see anything. Here we see that there are two concepts on which it is based. One is called as tunneling, and second concept is called as piezoelectric effect. One is tunneling, one is piezoelectric effect. So now what is done here, if you see this, we have a metal tip, and this metal tip is incident on the surface. It is, you can say in a manner, it is pressing the surface. While it presses the surface, it is able to produce electricity. It is able to produce some electrons here by applying this pressure. By pressing upon this surface, some electricity is generated. And this electricity generation, meaning that some electrons are generated here. Now these electrons can enter this surface. All right, these electrons can enter this surface, and that's why they will be able to analyze this surface. With the help of electrons, we'll be able to analyze this surface. So what happens here is there are two effects that takes place. One, the piezoelectric effect. So piezoelectric effect is when, with the help of mechanical stress or pressure, when you are able to produce electricity, it is called as piezoelectric effect, meaning that by just pressing upon the surface, when they are able to produce electricity, that is called as piezoelectric effect. So we see that in some of the solid forms, some of the crystal forms, we do see that piezoelectric effect takes its form. So piezoelectric effect is electricity produced by applying mechanical stress or pressure. All right, so electricity produced by applying mechanical stress or pressure is called as piezoelectric effect. Now in this particular scenario, when we say electricity produced, electricity always means flow of charge. In a manner, you can say, to simplify things, flow of electrons. So meaning that electrons will start to flow here. Now these electrons that are flowing, what happens is that the electron is able to enter the surface. So electron here, this surface that we have, the electrons will be able to enter inside the surface. All right, electrons will be able to enter inside the surface. So in a manner, what happens is that, let's say if this is the surface, suppose that if this is the surface, then the electrons, while traveling, they are able to go inside the surface. So in a manner, what we say is that they are able to break the energy barrier and enter inside the surface. It's not that they will be able to travel very easily. They will enter the surface and they'll not be able to go very far, but at least they'll be able to enter the surface and see what's inside. They'll be able to analyze the structure of this particular surface. They'll be able to see what exactly the surface is made of, what is the structure of uh, the arrangement of atoms in this particular molecule. So this is what we see in Ant-Man, the film, that the main character that you have, he's able to shrink himself to a size where he's able to enter inside what they call there in that film as quantum realm. So basically what they are trying to show is this effect, quantum tunneling effect. So tunneling is the concept that we are talking about when electrons are able to enter inside this surface. So Tunneling. Tunneling is when electrons or any subatomic particle is able to break the energy barrier of the material and enter inside it. This effect is called as tunneling or quantum tunneling, as we call it. So because of these two effects, because of these two things, what we see is that ultimately the electrons will be able to enter inside the surface, and then it will be able to analyze this surface. So this is how scanning tunneling microscope works. And because of this, now what we see is that because of the works of scanning tunneling microscope, now we could understand how exactly the surfaces look like, how these molecules look like. And now it opens up a new subject altogether, which is nanotechnology. So that's why you can say that uh, this was an early introduction for us in the world of nanotechnology. Sorry, parts of pen broke, it just fell down. Yeah. Huh. So this is basically how scanning tunneling microscope works. Now with scanning tunneling microscope, there is one drawback. The drawback is that we are using a metal surface, right? We are using a metal tip. Now because we are using a metal tip, unless the surface that we have here, the material that we have here, if it is not a conductor, if it is not, let's say, made of a metal, then in that case electrons will not enter the surface, because conduction will not happen here. And because of that, what happens is that electrons will not be able to break the energy barrier, right? The energy barrier can't be broken by the electrons, because flow of electrons cannot happen in a non-conductor, in an insulator it cannot happen, right? So that's why this method, or rather this microscope, is only useful for us when we have a surface which is a conducting surface, at least a semiconducting surface. Otherwise we can't work here. So that's why we see that there's another microscope that later became famous, and this is atomic force microscope. Force microscope came much later, but one drawback that scanning tunneling microscope had, this microscope is able to overcome that problem, right? So here what we see is that although the methods are pretty similar, that here also you are trying to scan the surface, but scanning the surface is done with the help of a laser, and we see that this will try to just map the entire surface. Atomic force microscope will try to map the entire surface, irrespective of whether it is a conductor or an insulator. So that is where we see that this is something that helps. So what we basically see is that in this scenario, as the tip moves across the surface, interacts with the sample's atoms, and generates a three-dimensional map of the surface, which can be used to determine the sample's roughness, texture, and all the other surface properties. So that's why, as you can see here, that you are able to actually analyze the surface like this by just having this cantilever and the tip, which are moving across the surface, and while they move across the surface, they are able to map this entire surface. So atomic force microscope, there are other types of microscopes as well, but these two became the most popular of the microscopes being used. So with the help of scanning tunneling microscope, now we had the ability that we could see at nanoscale. Now what we see next is that there was a discovery that happened in 1985, and this was called as fullerene. This was the first, you can say, the first nanomaterial to be discovered. This was the first nanomaterial to be discovered. And when we analyzed this nanomaterial, we were pleasantly surprised. And why exactly we were surprised? Because of the properties that it showed. It showed very good conducting properties, both of electricity and heat, good optical properties, and there are other things. The strength also was very good. So because of all these things, all of a sudden we understand that these kind of nanomaterials also exist in nature, and these can have significant properties that we could use in various different ways. So this in 1985, this discovery of a fullerene happened, and then in 1995 a Nobel Prize was also given to it. Now what you will see is that after 1981, the floodgates to getting Nobel Prize in nanotechnology opened. And you'll see that over the last 2 decades, a lot of Nobel Prizes have gone to nanotechnology. And this always happens whenever you have a new science in front of you. For example, 100 years back, when nuclear technology was new, you'll find that for each and every small discovery or a new invention, people kept on getting a Nobel Prize because it was new and everything that you found was probably new. So, and there were Nobel Prizes which were flowing in a particular family itself. For example, let's say you talk about Madame Curie. So she, because of her work in radioactivity, she got Nobel Prize. Her daughter also got a Nobel Prize in the same field. So everybody in the same field kept on getting the Nobel Prize. I mean, it was, you can say, the kind of scenario that we see in the film industry, where we talk about nepotism today. We see that something similar happens in the scientific world as well, that in the same family people are getting Nobel Prizes. And in the same scenario, 100 years later, we see that in case of nanotechnology, a lot of new uh, Nobel Prizes also keep on flowing in this particular segment. And that's why for each and everything, scanning tunneling microscope is invented. Then after that, fullerenes also get it. And then after that, there are so many things. Even uh, up till, you can say, 2021, 22, you keep seeing that there are so many Nobel Prizes that are being given to each and every discovery. So fullerenes became very, very crucial. This is the structure of fullerene. Now in this particular structure, if you look closely, what you see is that you have all these ball like structures, which are essentially the carbon atoms. These are the carbon atoms, and they are also connected to one another in a hexagonal manner. Correct? They are connected to one another in a hexagonal manner, and overall they are forming, you can say, a football like structure, right? Just like a football where you have all the threads and you have all the vertices, in a very similar manner you have the fullerene also. This kind of a structure is also called as Buckminster fullerene. Buckminster fullerene, made of 60 carbon atoms. Made of 60 carbon atoms. So also sometimes called as buckyballs. So another name that we use here is buckyballs. So what we see is that this kind of a structure was discovered, and this again generated a lot of interest in the scientific community because of the properties that we saw with this particular fullerene. After this, we see that there is another material that is synthesized, and this is carbon nanotubes. Now, in case of carbon nanotubes, also, if you see closely, you have the same hexagonal structures here as well, right? But this time arranged like a tube. In a tube like form, in a cylindrical form, we have carbon nanotubes arranged. Now, in this particular carbon nanotube, we see that the properties of carbon nanotubes are even better than what we saw with fullerenes. So even compared to fullerenes, we saw a much better properties in case of carbon nanotubes. And that's why carbon nanotubes, we see that there are a lot of great properties, a lot of advantages that it might be able to give us. So for example, if you look at the properties, high thermal and electrical conductivity, good optical properties, flexibility, increased stiffness, high tensile strength, even 100 times stronger than steel, lightweight, and ability to be manipulated while remaining very strong. So that's why we see that it's lightweight, it's strong, good electrical properties, good conducting properties, good optical properties, good tensile strength. So all of these packed in one single material, that is carbon nanotubes. So because of all these properties, we see that there are multiple different ways in which carbon nanotubes become essentially important for us. And we see that there are multiple different sectors or segments where carbon nanotubes become important. So for example, in electronics, we see that in electronics they can be used in creating conducting wires, in creating transistors, in even various different electronic components. For example, let's say uh, today we have so many foldable phones that have come, right? Samsung advertises it, other companies also have started coming with their foldable phones. So these foldable phones that we are making, carbon nanotube is a very important part of making that foldable surface, because it is flexible. We just discussed this, that it is flexible and it is very strong. So that's why you can actually make these foldable surfaces with the help of carbon nanotubes. So in foldable displays we can use it, in making transistors we can use it, in making the memory chips of computers also we can make the use of it. So in electronics we see that carbon nanotubes find a large number of applications. Then after that, in case of energy as well, so what we see is that we can also use carbon nanotubes to create various sources of energy. So for example, let's say in lithium ion batteries, or in fuel cells, or in solar cells, everywhere they can be used, because they have very good surface area. All right, they have a good surface area in this particular tubular form, and because of this surface area that they have a good conductivity. High electrical conductivity is basically coming from where, and energy efficiency also, energy storage also becomes easier because of that large surface area. Hence in the batteries they become very very useful. So in energy also, then in biomedical applications as well, we see that there are multiple ways in which they can be used. For example, I told you that in drug delivery we can use it, that we can basically use carbon nanotubes, insert it inside, let's say, a blood cell, and carry it to the required location. And that's why carbon nanotubes can be used there as well. At the same time, in making some biomedical instruments also, we can make the use of carbon nanotubes, because they are strong, they are flexible, they can be used there. At the same time, in cases of diagnostics and in imaging applications also, we see that they can actually be used because of their good optical properties. So that's why, because of those optical properties, in imaging things also, imaging instruments also, we can make the use of carbon nanotubes. So in drug delivery systems also they can be used, and they have unique optical properties, and that's why in imaging applications, and also in making biomedical instruments. Biomedical instruments. Then after that, in making composite material basically, to introduce better properties in these materials. For example, increasing the strength of material. So for increasing the strength of material, carbon nanotubes can be used, because when you mix carbon nanotubes, of course carbon nanotubes are very strong and lightweight, so that's why they can be used in making these material. Or to increase the strength of material, we can actually make the use of carbon nanotubes. So that's why in polymers, in metals, in ceramics, everywhere we can use carbon nanotubes to create these kind of superior material. Then they have environmental applications as well. Now in this particular case also, we see that in water and air filtration uh, techniques, or in making these kind of instruments for filtration, we see that there also we can make the use of carbon nanotubes. And again it goes back to its high surface area. Because of that surface area, we can very easily use it for filtration processes, and in removing contaminants from water. So that's why we see that this is somewhere we can actually make the use of this. So carbon nanotubes, essentially you can say that these are carbon fibers. All right, in a manner you can say that these are like carbon fibers. So that's why they can be used like membranes as well. They can be used like membranes, and they can be used in filtration processes. So in this particular case, we see that this is where in environmental applications also we see it, then in aerospace applications, because they are lightweight, because they are strong, so that's why they can actually be used in making aircrafts. They can be even used in making spaceships or spacecrafts as well. So in all these areas also we can actually make the use of uh, carbon nanotubes, also to make certain sensors or to create nanoelectronics. In all these cases also we can make the use of carbon nanotubes. So that's why when it comes to the applications of carbon nanotubes, the list is endless. These are only some examples where we see that today we are using it, and actively we see that there are a lot of areas where we see that in the future carbon nanotubes can be used very effectively. In the future, I'm very sure that there are all these areas where we'll start using carbon nanotubes a lot more. Active research is happening in all these fields to understand how exactly can we use carbon nanotubes to create all these things, a superior version of all these areas. So that's why in all these particular cases we see that in the future we'll be able to use carbon nanotubes much better than what we are doing today, right? There is one question. This question was asked in your paper in 2020. Please read the question. Option D is not visible. Option D is 1, 2, 3, and 4. 1, 2, 3, and 4. This is option D. Right? I'm not launching the poll for this question, and I'll give you the reason why. I hope you have read the question. You have your answers ready, but I'm not launching the poll for this. Okay. So the question says, with reference to carbon nanotubes, consider the following statements. First statement says they can be used as carriers of drugs and antigens in the human body. This is correct. We just discussed that they are much smaller than our blood vessels, compared to our red blood cells, etc. So very easily they can travel inside the bloodstream, right? So that's why one definitely correct. One definitely correct, because we just discussed about this. Second statement says they can be made into artificial blood capillaries for an injured part of human body. They can be made into artificial blood capillaries. Now whether they can be made or not, let's come back to this statement. Third is they can be used in biochemical sensors. They can be, and they actually are already being used in making these biochemical sensors. So for example, NASA also demonstrated some of these biochemical sensors with the help of carbon nanotubes. So already done, we are doing it. Fourth statement says carbon nanotubes are biodegradable. Now let me comment on statement number 2 and 4. 1 and 3 are, I would say, still a bit easier statements, but 2 and 4 are not. Second statement says they can be made into artificial blood capillaries for an injured part of human body. Now, creating artificial blood capillaries will be a very difficult task, because we are talking about capillaries inside our body and how they are arranged. So making that arrangement is not going to be an easy task. But the question says can be. So saying can't be, you have to have a very strong reason that why you are saying that it cannot be done. So I wouldn't say that it cannot be done. Have we done it today? The answer is no. Can we do it in future? The answer is yes. So this is, you can say, an active part of something called as tissue engineering. And in tissue engineering, these are the things that we are studying, that we are trying to understand that how exactly, if let's say somebody has been in an unfortunate accident, etc., how exactly can we regenerate their body organs as well, or can artificial body organs can be made for them. So body organs we are already trying, but at a level of blood capillaries we are still not there. But the question says can be, and it's not talking about any present state of development or whatever we have done until now. So then can be should not be marked as a wrong option. Can be, as I told you, can be anything. So if you say cannot be, that let's say if we mark it as wrong, then we are saying that it can't be done. So it can't be done today, you are saying that it can't be done in the next 100 years as well. So unless you have a very strong reason to support that it can't be done ever, then only you should mark it as wrong. Otherwise, I would say that it should be marked as correct. Option number uh, 2. Fourth statement is carbon nanotubes are biodegradable. Now, again, when it comes to carbon nanotubes are very strong structures, they are very stable structures, and that's why degradation of carbon nanotubes is not that easy. Degradation or biodegradation of carbon nanotubes is not that easy, because you need to have those kind of bacteria or other microorganisms that have the capacity that they could eat upon something which is as strong and as stable as carbon nanotubes. So again, this is something which is not that easy. In nature it is not that easy. So what we have been trying is to genetically modify certain microorganisms so that they can eat upon carbon nanotubes. Otherwise, generally speaking, when it comes to carbon nanotubes, and if we are trying to dispose carbon nanotubes, we use the process of incineration. Incineration. So what is incineration? Incineration is just providing heat to it, just burning it up. So incineration at more than 800 degrees Celsius. This is what we do if we have to destroy carbon nanotubes. So that's why destroying carbon nanotubes, calling them as biodegradable should not be correct. Calling them as biodegradable should not be correct. So if it was up to me, I would mark it as wrong. So if it was me, my personal opinion is that the answer should be 1, 2, and 3. But the official answer is 1, 3, and 4. The official answer given by UPSC is 1, 3, and 4. I certainly don't believe this is a correct answer, but this is the official answer that they have given. If it was up to me, I would have marked 1, 2, and 3. Unfortunately, there is no option that says 1, 2, and 3. In that scenario, I would have marked 1, 2, 3, and 4. That okay, fine, there are some microorganisms that we have created in the lab that could eat upon carbon nanotubes. So let's say, considering that, we can say that fine, call this as a correct statement. But there also it should have been carbon nanotubes can be biodegradable, can be made to be biodegradable. Are biodegradable? I don't think so. But this is it, this is what the answer is. So that's why I can't do anything now. uh, and in 2020, unfortunately, there were a lot of these kind of questions in science and technology, where I don't know why they asked this question. I mean, I really wouldn't want a panel like UPSC to ask these kind of questions. I mean, I want to understand why would you pick such a question. For example, even let's say biochemical sensor, not in the news, a part of research. It looks like somebody picked up, I mean, somebody just typed carbon nanotubes, and whatever Google showed them, they simply took some statements from the research papers and they gave it. I don't know why would you ask certain questions, because you are not asking a technical paper. It's not a technical paper, it's not a paper where you are going to recruit for a Ministry of Science and Technology. So I'm not sure. It's not a CSIR examination. So I'm not sure why even questions like these would be asked, but sometimes they do. I mean, I don't know what pleasure they get, but sometimes they do ask these kind of questions. But and I mean, that too, the answer is vague. I'll show you another question when we go to IT and communication chapter, where also I can contest the answer that they have given, because there are certain keywords which make the statements very ambiguous. So unfortunately, this is it. I mean, this is the official answer. I'm just writing it here itself so that you don't get confused. This is the official answer. This is the official answer, but I don't believe that this official answer is correct. Uh, but the correct answer that should have been 1, 2, and 3, but they don't even have it uh, in your options. So unfortunate to ask these questions. I don't know why would you ask these questions. So anyway, moving on. The next topic for us is nanowires. Now, in case of nanowires, we are talking about wires which have very small diameter, sometimes as small as just 1 nanometer. Now, these nanowires, they are made mostly of conducting or semiconducting material, and they can be used in various electronic devices. They can be used in the wiring of various electronic devices. At the same time, they also show very good optical and magnetic properties, because of which they can also be used in storage devices. So in this manner, we'll be able to store more data in a very small scale, at a very small scale, with the help of nanowires. Right, with the help of nanowires we can do that. So that's why with the help of nanowires, because they have remarkable optical, electrical, and magnetic properties, that's why we see that it can be used in, oh, I think the picture has blocked it. It can be used in the storage. It can be used in making the storage devices to store the computer data. So just like a hard disk, etc., you can create something which is very, very small and yet will be able to store a lot of data inside it, because of all these properties that we have. So that is the reason. That is the reason why nanowires also become very crucial. Then we have graphene. Now, in case of graphene also, if you look at the structure, you have the same hexagonal structure as well, right? Here also you have the same hexagonal structure, but this time arranged like a sheet. It is arranged like a two-dimensional sheet, you can say. Instead of being a cylinder or being a sphere, this time you have a two-dimensional sheet. Now, with graphene, what we see is that the properties of graphene are even better. One of the best conductors of heat and electricity, one of the strongest, or rather the strongest natural material that we have discovered. So all these things again in the same material, and stacks of graphene, one over the above, that is what forms graphite. So now, in case of graphene, when the discovery of graphene happened, this discovery was a very unique discovery, and at the same time, it also generated a lot of interest that this is also possible. Something like this is also possible. We realized this, and the kind of properties that graphene showed, we thought that it's going to change the world. And this was a discovery which was kind of an accidental discovery. So what happened with the discovery of graphene was that a couple of scientists who were playing around with graphite, they basically were using the sticky tapes, or the cello tapes as you call them, on graphite, and they were just peeling the surface off. They were just peeling the surface of graphite, and that is where they were able to peel off the surface, and they found that graphite is made of graphene. So this is how discovery of graphene happened, with a simple sellotape. All right, with a simple sellotape, we saw that the discovery of graphene happened. So it could have been any one of us playing around with the sellotape on our pencils, and we could have been the discoverers of graphene. But unfortunately, we were not there. They were the ones there, and they actually were able to discover graphene. Now, this discovery of graphene was unique because we found one of the best conductors of electricity, one of the best conductors of heat at room temperature, one of the strongest natural compounds that we had ever discovered, and one of the thinnest compounds known, with just one atom thickness, because it's just like a two-dimensional structure, right? Two-dimensional structure like a sheet. So that's why we are saying one of the thinnest material that we found, and that's why it was also called as miracle material. It was also known as miracle material because of all these different properties that we could see on one single material. And that's why it was said that now it's going to change the world. If you look at the articles that were published at the time, you'll see that most of the articles are talking about how graphene is completely going to change the world as we see. But almost 20 years later, nothing has changed. Graphene has not really taken over the world as it was supposed to, but yes, it is still being used. For example, it can enhance the strength of other material, to making the composite materials, just we discussed, as we discussed in case of carbon nanotubes as well. Something similar with graphene also, in making LED lighting, in making electronic devices, in batteries, in case of uh, corrosion barrier between oxygen and water diffusion, also useful in water purification. So there are all these different types of use where we see that graphene becomes important for us. Although the kinds of properties that we are talking about in terms of graphene, they are so unique that it should have done much more than what we see here, right? It should have completely, as I told you, that if you look at the articles that were published after the discovery of graphene, it's about it, they all talk about how graphene will completely change the world. But it hasn't changed the world, right? It hasn't been able to change the world because there are certain limitations. Limitation, first of all, cost is a big limitation, because if you want to use graphene somewhere, you need to also ensure that it is cost effective, because if it is not, then it is not useful. So in a lot of cases we see that it is not cost effective. So for example, if you're saying that it is one of the best conductors of electricity, why not use it in wires? Just make electrical wires all across with graphene. Can you do that? You can't, because when you use copper or aluminum, they are much cheaper as compared to graphene. So that's why uh, we see that it's not really possible for graphene to replace the electrical wiring where aluminium or copper is being used. So same goes for other areas as well. Wherever graphene finds is used, there is something that is already working, which is doing a decent job, and at the same time is also cost effective. So that is where we see that graphene only found its application in areas where nothing else could work, in areas where there was no substitute for graphene, and there was nothing that is even comparable to graphene. So that is the only, these are the only cases where we see that graphene is actually being used. This question, this was asked in your 2010 paper, 2011 paper. 2010, the Nobel Prize was given for the discovery of graphene. 2004, the discovery had happened. 2010, the Nobel Prize was given, and 2011, this question was asked. So if you have read, I'll launch the poll also for you. Hmm. So 73% of you have marked C, which actually is the correct answer. So let me discuss this with you. Graphene is in news frequently. What is its importance? First, it is a two-dimensional material and has good electrical conductivity. Two-dimensional, correct? Like a sheet. Good electrical conductivity. Good is an understatement. One of the best conductors of electricity. So that's why one definitely correct. One of the thinnest, correct, but strongest material tested so far, correct. This is also correct. It is entirely made of silicon. This is wrong, because it is made of what? It is made of carbon. Made of carbon and has high optical transparency. Made of carbon, we discussed that the discovery even happened from where? The discovery happened where they were playing around with graphite. So that's why it's made of carbon and not made of silicon. So 3 is wrong. 4, it can be used as conducting electrodes required for touchscreen LCDs and organic LEDs. Yes, they can be. And in OLEDs, basically we use graphene, which also makes the OLEDs very costly. So for example, there are OLED TVs that are there in the market, being produced by LG, and Sony also sells it. So you'll see that the market price of the OLED televisions of LG and Sony, they are very very high compared to a normal LED television. So because of, one of the factors is also the use of graphene there, which increases the cost of this technology. So 1, 2, and 4. So correct answer will be C. Then the next material that we have is a quantum dot. Now, in case of quantum dot, understand why the name quantum dot. Quantum, because it is at a level which is very small. It's almost at molecular or atomic scale, 1 nanometer size. So that's why the term quantum is being used. And dot mainly because these are spherical surfaces. So these are spherical. So for us, from where we are looking at, it's nothing more than a dot for us, right? And anyway, we can't see it, but even if we were able to, we can imagine it as a dot. So that's why the name quantum dot. Now, what's special with quantum dots? That when you are using quantum dots, when ultraviolet light is passed through quantum dots, they are able to show various colors. The color that they would show also depends on the size of the quantum dot. A bigger sized quantum dot will show red color, whereas a small sized quantum dot might show a blue or an indigo or a violet color. So depending on the size of the quantum dot, we see that there are various colors that are emitted, and which is based on what is the color that they will absorb and what is the color that they would reflect, and based on their size. Because when you look at the electromagnetic spectrum, we know that the big, and we discussed about this in space technology, the longest wavelength that we have is with the radio waves. So after radio waves you have microwaves, after microwaves you have infrared, after infrared you have the visible light. But the first part of the visible light is red. That's why after infrared, red comes. So red has the longest wavelength, and then lastly you have violet. After that comes ultraviolet. So ultraviolet has a smaller size as compared to violet, correct? So that's why when you have a smaller size quantum dot, you will see that they would emit violet or bluish color, and when you have a bigger size quantum dot, they would emit reddish color. All right, so color has a reason. The reason is the wavelength. So quantum dot, this is what we see, that when you have ultraviolet light on, they would show various different colors. Now, in this particular scenario, what we see is that why ultraviolet light? Because ultraviolet light has a very very small uh, wavelength, and these quantum dots are at the size of these nanomaterials. So quantum dot also can be said to be a semiconductor nanoparticle, which is less than 100 nanometers in its size. Now, when it comes to quantum dots, here also we see that there are multiple different things. So for example, when their application comes, they can be used in photovoltaic devices, they can be used in LEDs as well. So there is something called as QLED, also called as quantum LED. So this quantum LED also is a technology that is very often used in televisions. So for example, let's say Samsung is one of the biggest companies when it comes to QLED TVs. So when you look at the cost of a QLED TV, you'll find that it is higher than a normal LED TV. So the reason again is because quantum dots are being used. Now, if you look at the advertisements, wherever the advertisements of any QLED TV is being put forward by, let's say, a company like Samsung, they would always say that you get better color contrasts in QLEDs compared to any other TV. So compared to a normal LED television, you'll get better colors, better contrast. Why? Because QLED is using quantum dot. Because with the help of quantum dots, they would be able to produce all these various colors much more efficiently as compared to a normal LED TV. And that is why they advertise that QLED will have a better color contrast as compared to a normal one. All right, but they are, of course, they are also very costly. So they can be used there, they can be used in the medical field as well. For example, we see that in the diagnosis and treatment of cancer also, quantum dots become useful. And then also they can be used as a photocatalyst in driving the chemical conversion of water into hydrogen. So in the electrolysis of water also, we see that we can make the use of quantum dots, and there also it can be used as an electrode. So there are again multiple different ways in which we see that quantum dots become useful for us. So overall, when we look at nanotechnology, we find that there are various different sectors where we find the use of nanotechnology. For example, in drug delivery. In drug delivery, gold nanoparticles can be used, or even we discussed that carbon nanotubes can also be used. I'm writing CNT, I'll write carbon CNT for carbon nanotubes everywhere, right? So even carbon nanotubes can also be used here. Then in tissue engineering, we discussed about this in through that question. So there also carbon nanotubes are actually useful. Then in disease diagnostics as well, we see that we can make the use of various nanoparticles. For example, carbon nanotubes can be used there, or even quantum dots also can become useful. Then as nano carriers for eye surgery, because these are very small particles, they can be used. So many a times we see that metal ions can be used here in making the nano robots. So these also are where we see that carbon nanotubes can be used, and making nano flares in breast cancer treatment. This is where we find that quantum dots can become useful. So there are all these cases where we see that in one way or the other, one material or the other becomes useful. Similarly, in addressing energy, so addressing the shortage of fossil fuels, we can increase the efficiency by using some of these nanomaterials, especially something like a carbon nanotube can be very useful. Even quantum dots are being used for hydrogen production. So that's why in all these cases we do find their use. Then in making nano generators for wind energy production, in making the solar cells, there also we discussed about carbon nanotubes. In making the QLEDs, we discussed the quantum dots, how they can be used there. And in making the nano catalyst for hydrogen production, there also quantum dots can be useful. So that's why in all these cases, in addressing the shortage of energy, we find that all these various nanomaterials can be useful. Then in food and agriculture, we have silver nanoparticles that have antibacterial properties. We have antimicrobial nano emulsions that we also use. And in many of these cases, what you'll find is that in food and agriculture, largely metal ion nanomaterials are being used. Metal ion nanomaterial, meaning that the nanoparticles are made largely of some kind of metal. It could be silver, it could be gold. These are the most popularly used materials, but there can be other semiconductors, etc. as well. So metal or semiconductors. So for example, titanium dioxide. So titanium dioxide also having antimicrobial properties, it can also be useful. So there are multiple different ways in which we can make the use of nanomaterial. Most famously in nano fertilizers. So for example, you might have heard of nano urea, has been in the news very often. Nano urea. So in making nano fertilizers also we can use nanotechnology, because these nano fertilizers, they have higher surface area, so their absorption rate, their efficiency is better as compared to the normal fertilizers. So that's why we see that in all these cases, actually we can make the use of uh, nanotechnology, and we already have been doing this last couple of years. It has been very much in the news as well. Then in the environment, so in water purification, we discussed that it can be used. For example, we know that graphene becomes useful in doing so. Then nanomaterials to reduce carbon dioxide, again carbon nanotubes and graphene both can become useful in such a scenario. Then pollution control with the help of metal oxide nanocrystals. Then improving the air quality because filtration can be done, and also to make nano sensors for detection of pathogens. So here also we see that carbon nanotubes, they become very crucial in making this. Then in electronics, in making nano circuits, we can make the use of nano wires here. In making MRAMs also, nano wires can become very useful, because they would be able to store a lot of memory in a very small scale. Then the use of carbon nanotubes in electronics, we discussed about this. In making the foldable displays, again carbon nanotubes and also graphene is very very useful in doing this. So in all these cases, in let's say even in reducing energy consumption, we discussed about the QLEDs. So we find that QLEDs basically they have a better energy efficiency as compared to any other the other LED technologies that we are using. So in all these cases, we do see that it can be very very useful in electronics as well. Then in various industries, for example in aircraft manufacturing, in construction industry, in textiles, everywhere, even in making COVID-19 masks, we have made the use of nanotechnology. So aircraft technology or construction industry, we see that carbon nanotubes become very very useful in all these cases. Then even in textiles, again we find that carbon nanotubes can be useful in this particular scenario also. Then in space technology, so to reduce the spacecraft weight, we know that carbon nanotubes can be used. We discussed about this, that they can be used. And there is this particular concept of space elevator. Now, this space elevator is a very unique concept. Today, we see that NASA is working on it, European Space Agency is working on it, Japanese Space Agency is working on it. So they all have been working independently. They have been working on their own projects of space elevator. So you know that elevator, the lift that can carry you from one floor to another in a building. Similarly, they are making an elevator that can go from the Earth and can take you to the space station. So they are trying to make an elevator between a space station and the Earth, so that they can carry people and objects from the Earth to this particular place. So seems almost impossible, right? But they have been trying. They have been trying for the last 20, 30 years, I would say, that it has been in the making. The wire that they are making here, they say that the wire will be made of carbon nanotubes. So this is the space elevator concept. I remember that this concept of space elevator is something that um, I would have come across first maybe when I was in class 6th or 7th, and there was an article that was published. the, there is a newspaper. I mean, for those of you who are from Bengal or maybe Jharkhand, you might have come across that newspaper, the Telegraph. So the Telegraph basically used to have one magazine on Mondays called as Know How. I think Know How now has become just a page in the newspaper, but it used to be a magazine on Mondays where they just used to talk about science, various different things happening in the world of science. And there was one article published on space elevators, a very unique concept. And we had a science exhibition just coming in 1 month. So I along with my friends, we decided that we'll make a model of this space elevator and present it there. So we did that. And we won the first prize because nobody understood what we were doing. Nobody knew what space elevator is, what carbon nanotubes are. So whatever we explained, even we did not know what we are explaining. We had just uh, by hearted everything, and we went there. And the judges also, they probably also did not understand. They just kept saying that it's a very unique concept, very unique concept, because everybody else making volcanoes and everything else, we were making space elevators. So we got the Nobel Prize for nothing. I mean, sorry, not the unfortunately not the Nobel Prize, but at school level it is equivalent of you getting Nobel Prize at international level. So we got the first prize for making this space elevator. So a concept that I'm talking about almost, let's say, 20 25 years back. So still in the making, obviously one of the most difficult things that you can think of. But NASA is working, European Space Agency working, Japanese Space Agency working. So they've all uh, made this concept. They have all been working on this concept for a very long time. So we see that in all these areas there are so many ways in which nanotechnology, we see that potentially becomes very very important, because many of these areas of application that we are talking about, these are not areas of application that is functional today. These are active areas of research and development, active areas of study, a lot of papers being published here. So that's why all these things are more for the future than for the present. Even in military applications, in intelligence gathering, we can make the use of nanowires, because nanowires can make very very small circuits which can even store data. They can also capture data, and they can be used to make spy devices as well. in making military vests, to make bulletproof clothing or stab proof clothing, we have been trying to understand how carbon nanotubes can be used there, because carbon nanotubes are carbon fibers. We discussed that these are carbon fibers, so just like clothing. So carbon fibers can be made, and these carbon fibers made of carbon nanotube will be strong, will be flexible, will be lightweight. So that's why even for the military, the movement is easy with these kind of vests. So, and even in wound care, we discussed about tissue engineering and how tissue engineering can take its shape in all these cases. All right. So what we see is that the applications of nanotechnology, there is no limit. I mean, what we have been talking about and all these examples that I have given you, these are only some examples. There are hundreds of such examples where carbon nanotubes is taking its shape today. This question, 2015, this question was asked. Please read the question, and let's, it's an easy question, not a very difficult one. All right, I'm launching the poll for you. Please mark your answers. Hmm. So 66% of you have marked C, 24% A, 7% B, and 3% D. With reference to the use of nanotechnology in the health sector, which of the following statements is or are correct? First, targeted drug delivery is made possible by nanotechnology. Yes, it has been made possible. Nanotechnology can largely contribute to gene therapy. Can it contribute? Because it is contributing in drug delivery in a very similar fashion, it can also help us in gene therapy also. And in gene therapy, we see that carbon nanotubes or in general, nanotechnology is being tried upon. And the statement says can largely. So can largely means that yes, it can be. So, and because it's a very similar process, both of these processes, they are very similar to one another, and hence both of these actually are correct. So correct answer will be both 1 and 2. Now coming to the Indian initiatives, that what have we done in India with regards to nanotechnology. Now, as always, we have been a little late to arrive at this technology as well, but we have caught up very fast. We have caught up very fast. Initial couple of decades, you can say that we have been very slow, but then after that, there are certain things. For example, let's say initially, uh, for the first time, research in nanomaterial was promoted in the ninth five-year plan. Then after that, there was a program on nanomaterial science and devices by the Department of Science and Technology in the year 2000. So these were small initiatives here and there that the government was taking, but it all changes in 2007, because in 2007 we took something called as the nano mission. We took the nano mission, and this nano mission was a part of the 11th five-year plan. So for 2007 to 12 period, this was taken as a part of 11th five-year plan, and we saw a lot of success there. We saw a lot of success, and because of that success, it was also extended for 5 more years, and it was also made a part of the 12th five-year plan in 2012. So from 2007 to 17, now it was extended for 10-year period. Because of that, today what we see is that a lot of uh, you can say help, a lot of support, a lot of funding was provided by the government to all the kinds of research that is happening in nanotechnology. And that's why we see that the number of research papers that we kept on publishing, that also increased. Today, just going by data, if you just go by the data of the number of papers that have been published, research papers that have been published in the field of nanotechnology, you'll find that India is among the top 3 nations in the world. US has the highest number of papers, followed by China, followed by India. So that's why India is among the top three nations in the world when it comes to publishing of research papers in nanotechnology. So that itself shows that how we have been able to grow in our understanding of nanotechnology, how this field, because the field got a support from the side of government, the students, the scientists, the engineers, they could work in this particular field. So when it comes to this nano mission, basically you can say that it's an umbrella mission. There are five basic objectives that were taken as a part of this nano mission, and we were able to work upon all these five objectives. So just understand what these five objectives are. First is a basic research promotion. So basic research promotion is mainly about, let's say, funding of certain projects which have been taken by certain scientists or maybe a group of scientists, then providing them centers of excellence where they can come together, collaborate, etc. So these kind of basic research facility or basic research support was provided by the government as a part of this mission. Then after that, the infrastructure development for nanoscience and technology research, this was also very very important because the infrastructure etc is very costly when it comes to nanotechnology. Something as simple as scanning tunneling microscope or atomic force microscope, which is required for the research, it is very very costly. It could cost up to rupees 10 lakhs or more for one single microscope. So for an individual scientist, for an individual engineer, it may not be possible for them to just keep buying all these things so that they can do their research. So these all supports also were provided by the government uh, under this particular mission. Then after that, we also see that nano applications and technology development programs were taken. So under this program, under this part of the objective, what we wanted to do is that a lot of research that is happening, research should be based on practical solutions and for providing practical solutions to the problems of the day. That if industries are facing certain issues that could be solved with the help of nanotechnology, then the research should rather focus on this instead of just doing an independent research which does not have a bearing on the industries in real time. So that is why we see that this kind of point was also noted, and this was a very crucial point, that where we are actually trying to solve a real life problem instead of just doing a basic research. So that was also a part of it. Then human resource development. So in case of resource development, it was about providing effective education and training to the researchers and the professionals in the diversified fields. So in this particular scenario, we see that in all these cases this could also happen. uh, about the training of the scientists, of the engineers. Not only that, we also needed to provide an IPR framework. We'll discuss about IPR later, but we wanted to provide an IPR framework. We wanted a legal and a legislative framework to also be present. So for all this also human resource development was required, and this also happened. And then lastly, international collaborations. I don't know, some kind of alignment problem has happened here, but when we talk about international collaborations, what we saw was that Indian scientists also started collaborating with some of the foreign scientists. A kind of knowledge sharing happened, which also helps both the communities. A lot of seminars or conferences happening on nanomaterials. Indian scientists were also sent there. The government of India also provided monetary support for going and coming back and all that. So we see that these kind of collaborations also helped the Indian infrastructure and the Indian scientists to grow better in terms of nanotechnology. So that's why we see that there are all these objectives that were taken as a part of the nano mission, and it certainly helped in understanding the various aspects of this nanotechnology. Then coming to the problems, the challenges that we have today in India with regards to nanotechnology. That although we are saying that yes, in terms of number of research papers published, we are among the top three nations in the world. But at the same time, if you look at the actual advancements that have happened in India, they are very limited in number. The actual number of things that we have done with regards to nanotechnology, it's very limited in number. So there are certain issues that we have, and the issues that we need to address if we uh, want a better application of nanotechnology. So first, improvement in the efficiency, reliability, and the safety of nanotechnology and the products which are associated with nanotechnology. that we need to understand that how we can increase the efficiency, we can increase the reliability, and we can make the products much safer, even for, let's say, public consumption or wherever in general people are related. Then after that, the technology cost. So as we discussed that the cost of acquisitions of intellectual property rights or nano technology infrastructure is very costly. Getting the rights for all these materials or licenses for all these materials can be very costly, because these are new technologies. Anyone who is working on it, anyone who has invented something new, they would also have spent a lot of money. So that's why it's not going to be easy for us also to acquire those technologies in the country. So it's going to be very, very costly. Then the safety, health, and the environmental risks to the consumers, that also needs to be addressed. That where are the risks, what is the risk, how exactly should we mitigate those risks, the health implications that it can have. All these issues also have to be well understood, so that we can also um, talk to people about this. Then a poor lab firm integration. Now, when we say lab firm integration, the meaning of lab firm integration is that we see that not a lot of research and the studies that are happening in nanotechnology, they are actually related to what the industries demand. Although it was a part of the nano mission that this is how the solutions should work, but we still see that that kind of a collaboration between the two is pretty limited. So that's why we are saying it's a poor lab firm integration, that between the companies, the industries, and the research, we don't see that there is a lot of uh, collaboration. So that's something that needs to improve. Because look at, for example, something like artificial intelligence, that how the concept of artificial intelligence has been used by various different industries, right? So something similar needs to happen with nanotechnology as well, for the future of technology. Then one of the problems also is the interdisciplinary nature of nanotechnology. See, when we talk about space technology or nuclear technology, biotechnology, these are branches of technology which are independent. That if you are an expert of biotechnology, you have to be just an expert of biotechnology and not of nuclear technology. Same goes for if you are an expert of nuclear technology, you need not have to think about biotechnology and uh, how or expertise in biotechnology. But that doesn't work in nanotechnology, because nanotechnology is an application based science. So it's not really related to only nanotechnology, but you have to provide solutions. You have to provide solutions to space technology, you have to provide solutions to nuclear technology, you have to provide solutions to biotechnology. So it's a solution based science, it's an application based science. So only having the knowledge of nanotechnology research is not enough. Unless you have a good knowledge, working knowledge of some other segment as well, and you know how to apply that to those segments, until then it cannot really work a lot. And then lastly, the regulatory capacity, information asymmetry, and the absence of, I think it's hidden here, absence of interagency coordination. This also is a problem, that we see that very often a lot of government entities also, they keep on working independently. So for example, let's say if we talk about, we have Ministry of Science and Technology, and we also have Ministry of IT and Electronics, right? We also have Ministry of IT and Electronics, and we have Ministry of Science and Technology. Many a times the work that they are doing on nanotechnology, they are doing it independently, they're not collaborating together. They could have also discussed the same things together and maybe come forward together. But there are these two ministries which are functioning completely separately, and hence many a times we see that there is no coordination between the two. So that's why that also is required if we want a good growth of nanotechnology in India. So that is also one of the issues. And then lastly, the concerns, the problems that we have with nanotechnology. So overall problems, if you see, first and foremost, it's about nano pollution. That how we see that, because these are nanoparticles, these are very, very small particles, they can very easily accumulate inside our body. Right? They can also very easily accumulate inside the body, and they can reside there for years before they start to show a negative impact. It could be 10 years or maybe 15 years before you actually start seeing the impact of nano pollution, or maybe the nanomaterials that are getting just deposited inside our body, maybe because of the air that we are breathing. It can have those particles that will just go and deposit in the lungs and then start showing problems maybe 15 years later. So that's why we see that nano pollution is a big problem. Similarly, in the same context, you can think of this point, that is about buckyballs being found in fish. Buckyballs or fullerenes have been detected in the fish. So there are two concepts environmentally, one called as biomagnification and one called as bioaccumulation. So biomagnification and bioaccumulation of nanomaterials can actually keep on happening of nanoparticles. So that's why we see that all these kind of problems are there. You might also have heard of the term microplastic. Again, has been pretty much in the news in the last few years. Microplastics. So in the case of microplastics, what do we know? That these are very, very small particles of plastic which could be just suspended in anything that is made of plastic. For example, there was a research that was done, a study that was done on all the packaged drinking water, biggest of the companies across the globe. They found that there were microplastics present in the water that they are giving you. So all the claims that they have, that this is a pure water coming from the Himalayas, and uh, this water and that water mineralized and all these things, ultimately microplastics were found in the biggest of the brands, whether it is your Kinley or Bisleri or Aquafina and whatever you are uh, consuming. They had found microplastics in all these company bottles. So that's why uh, even drinking in a plastic bottle is not a good idea. Long term, not a good idea. If once in a while, it's fine, but otherwise it's better to always carry something for water which is not made of plastic. Please make sure that you also inculcate this habit, if at all possible for you, that don't use things made of plastic, because ultimately what happens is that they might have a long term negative impact. They may not have. I'm not saying that they will have. I'm saying they may have. So that's why you have to be just aware of these kind of things. Then we see that there is a nano arms race also that is happening. That we see that all the nations, most many of the biggest nations of the world, they have been trying to make something which is made of nanomaterial, which is based on nanomaterial. So all these things are also happening. Then they are expensive. We discussed that OLEDs are expensive, QLEDs are expensive. Wherever you are making the use of graphene or carbon nanotubes, they are expensive. In medical science also, wherever they are being used, they are expensive. So that also becomes a challenge. Then the problem of titanium dioxide in sunscreen. Now, titanium dioxide is used in the sunscreens, and titanium dioxide will be able to protect you against ultraviolet light. Uh, but and there were so many advertisements that if you see the sunscreen advertisement, they will show you that the sun rays are coming and they will just come to your skin and they would just reflect off your skin. Why would they? Because there is titanium dioxide that you have used in through your sunscreen. Now, titanium dioxide was being marketed, being advertised everywhere. All of a sudden, there was one research that showed that if you are using a lot of titanium dioxide, it is potentially cancerous. It can cause skin cancer. So then after that, there was a regulation that was brought in that only certain limit, I think it was 10 nanograms per ml or something like that, that not more than this is used, has to be used in the sunscreen. So that happened later. Before that, already we were using titanium dioxide in the sunscreen without understanding the possible implications that it could have on your health. So that's why we see that there are all these kind of issues that we have faced. Then cadmium selenide nanoparticles, which can lead to cadmium poisoning. So cadmium selenide is basically used in quantum dots, right? It is used in making quantum dots, so it can lead to cadmium poisoning. And then the lack of risk analysis and regulations, that also is a big challenge, because we see that it's a growing science, it's a new science, so there are not a lot of laws and regulations, etc., across the world. So that's why a lot of uh, researches are just happening blindly, because without having any thought about the negative impact that it might have. So that's why there are all these problems, all these concerns that we have today with regards to nanotechnology. Look at this question. There are actually two questions that have been asked from this particular part. So we'll discuss both the questions one by one. Read this question. I'm launching the poll for you. Please mark your answers. So 66% of you have marked D, which is actually the correct answer. 16% A, 2% B, and 15% C. All right. There is some concern regarding the nanoparticles of some chemical elements that are used by the industries in the manufacture of various products. Why? First, they can accumulate in the environment and contaminate water and soil. This is correct. That's why we are talking about nano pollution, that they can actually accumulate in the environment and they can cause contamination. So, in a manner, a bioaccumulation that we see inside the body of the animals, they are actually also happening from here. They can enter the food chain. Yes, they can. That's why biomagnification. That if they are found in fish, for example, we discussed the example, they are found in fish. So this fish will be eaten by somebody else or some other animal. That animal will also get nanoparticles from there, and in this manner, from one trophic level to another, we see that it will keep on magnifying. So one is correct, two is also correct. They can trigger the production of free radicals. Even this is correct. Now, production of free radicals. Free radicals basically are what? These are charged particles, right? These are charged particles which are present inside our body. And if the number of these charged particles, the amount of these charged particles is are high, then they could have some implication or on our body. To protect against these free radicals, we use something which is called as antioxidants. We use antioxidants against this. So a very widely used term, antioxidant, widely advertised term, is something where we see this. So antioxidants can be used. So that's why charcoal. So the charcoal discussion that we did, the charcoal is required so that they can protect you against the production of free radicals by being used in antioxidants. So that's why this is called as radical scavenging. This is called as radical scavenging. So radical scavenging, for example, let's say we discussed about uh, fullerenes. So fullerenes basically are examples of very good radical scavenging. And where are fullerenes formed from? They are formed from carbon particles, the carbon soot. That's why charcoal. So charcoal and fullerenes, they have very shared properties in this particular manner. So that's why charcoal is being used as an antioxidant. And that's why all your toothpaste and soap and face wash and whatnot, everything has charcoal in it, right? So that it can act as an antioxidant against the production of free radicals. But it's not that you need something externally all the time for these antioxidants. There are a lot of fruits and vegetables that you can also consume, which are good, which have good amount of antioxidants, and body in general also knows how to produce antioxidants as well. So it's not that you need to eat charcoal to get these antioxidants. So correct answer will be D. One last question before we take a break. Please read this question. This was asked last year, 2022. This question was asked. I'm launching the poll. Please mark your answers. Hmm. So 79% of you have marked D, which is absolutely the correct answer. Let me discuss this for those of you who are confused. First statement says, other than those made by humans, nanoparticles do not exist in nature. Do not exist in nature. First of all, extreme. Second, we discussed about fullerenes, that fullerenes were discovered, correct? Fullerenes were discovered, graphene was discovered. So all these are particles which have been discovered. So that's why they exist in nature, that's why they have been discovered. Otherwise they would have been invented, if not, if they did not exist in nature. So that's wrong. Nanoparticles of some metallic oxides are used in the manufacturing of some cosmetics. Yes, they are used. We discussed about titanium dioxide in sunscreen. So yes, they are used. Nanoparticles of some commercial products which enter the environment are unsafe for humans. That's also correct. That's why we are talking about nano pollution. And again, you can take the same example of sunscreen. So correct answer, that's why here will be 2 and 3. All right. So let's take a break here. It's 7:47. So let's be back by 8. And meanwhile, any question if you have, please post all your questions so that when we are back from the break, I'll take your questions and then we shall move forward. Welcome back, everyone. Let me take your questions first and then we'll proceed. What is solid strap-ons of GSLV Mark III? Solid strap-ons basically are the extra thrusters that are provided. If you watch closely, you'll see that there are smaller rocket-like structures that you'll see that they are bound all across the main structure. So they are called as strap-on motors. The US company signed letter of intent to invest 820 crores in producing geothermal energy in Uttar Pradesh, but Uttar Pradesh is not a geothermal hotspot in India. Then how is it possible? There are areas where they actually are going to do the research and try to find whether there are possibilities of doing that. There are areas of the eastern and the northern side of uh, Uttar Pradesh where there are certain areas that can be considered. Which one is efficient? Pressurized heavy water reactor or boiling water reactor? Pressurized heavy water reactor is more efficient as compared to boiling water reactors. These nanowires are good conductors of electricity. Yes, 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 they are. Can carbon nanotubes be used in ICT? ICT full form, can you tell me? Why nano urea is liquid, not solid? See, the basic reason why it is in the liquid state is how we want to use it. Because there are two basic ways, two basic reasons why it is in the liquid state. So, first thing is that when we talk about this being in the solid state, then it will be particles. The absorption rate of particles in the particles will be much lesser, all right, compared to when it is in the liquid state, where absorption will be much easier as compared to when it is in the solid state. Secondly, it also ensures that the effective amount of urea getting absorbed is higher and the runoff happening of this kind of a urea is lower. So from that perspective, we see that it also becomes very, very useful for us if it is in the liquid state rather than in the solid state. Concerns of carbon nanotubes of point number 3 and 4. Concerns carbon nanotubes point number 3 and 4. So are you talking about, so point number 3 here is that it is expensive. We discussed that wherever you are using graphene or carbon nanotubes in electronics specifically, we know that it is expensive because the customization required, the manufacturing required, all that takes a lot of effort and money. So that's why it is expensive. And buckyballs are nothing but the fullerenes. Fullerenes have been found in fish, and it means that now we see that uh, nano pollution is not just a theory but something that examples are already available with us, and this will lead to bioaccumulation within the species and biomagnification in various trophic levels. So that is what we are seeing here. We can understand that photo means light and catalyst is something that expedites a process, but can you please explain what are these photocatalysts with some examples? So any photocatalyst is basically when you are looking at any photovoltaic device or anything that can help in any process where some kind of light related applications are related to. I mean, wherever you are trying to expedite a process where ultraviolet light or visible light, etc., they are involved. So in all these cases, photocatalysts are used. So for example, let's say in case of solar cells as well. So in case of solar cells, we are making the use of sunlight. But if we want to enhance the properties of these semiconductors, we can use uh, we can use a photocatalyst there. Or wherever we are making the use of sunlight for any kind of purpose, for any kind of application, we can make the use of photocatalysts in these kind of cases as well. So that's why we see that photocatalysts can become useful in all these kind of cases. So I think that exercise the process, but can, yeah, so this is basically what it is. So overall, just remember that in these kind of cases we can make the use of photocatalysts in various different devices. So for example, we discussed titanium dioxide. So titanium dioxide also can be used as a photocatalyst. So there, for example, let's say in nanotechnology we also talk about self-cleaning surfaces. So these self-cleaning surfaces can be made with the help of titanium dioxide, where it can actually uh, it can be used as a photocatalyst. So in solar energy, it can be used. Titanium oxide can be used. Then other semiconductors like zinc oxide can also be used. So zinc oxide is also used as a photocatalyst, where we see that wherever you have uh, uh, ultraviolet light, when you want to provide a protective coating to ultraviolet light, you'll see that zinc oxide is being used there as a photocatalyst. So we see that there are multiple different things like this which can be used. Most of these, just remember that most of these examples of photocatalysts, they are semiconductor in nature. All right, they are semiconductor in nature, and that's why they respond better to light, they respond better to sunlight, etc. So I hope that this clears your doubt. In cloning, we don't talk about DNA in the mitochondria. Is it due to species specific DNA in it? Uh, See, yeah, the basic reason is what you have stated, that when we talk about the DNA or the kind of DNA that we need, is basically the DNA that we have in the nucleus, because mitochondrial DNA will be the same. So even if we don't transfer those DNA, we do nothing to those DNA, it doesn't matter. But nuclear DNA become very very crucial for us, because otherwise the properties will be of the donor. So that's why it becomes very very crucial for us to ensure that the nuclear DNA are taken care of. Is the concept of PIM particles exist? uh, are you talking about ant-man here? Because PIM particles, I think, is a concept in ant-man. No, it's not an original particle. I mean, if you're talking about Dr. Hank, who is said to be in Ant-Man, one of the leading superheroes in Ant-Man universe, he is somebody associated with the PIM particles. But these are not. I mean, if you're talking about that PIM particle, then no, it's not an actual particle. It's in the cinematic universe only, the comic universe. So ICT is in information and communication technology. Yes, I mean, nanoparticles can become useful there, and we'll discuss that when we go to IT and communication. We'll have a discussion on it as well, so don't worry. How this term nanotechnology is going to help in each and every sector to our country, as per we know that it is in an expensive commodity. Also, India is not much skilled workers. So in future, uh, we are going to not compete with global north countries. See, right now, yes, it is expensive. That's why it's very limited research that we also have been doing. And we right now are not trying to solve a problem that does not exist. We are trying to solve problems which are genuine big problems of the day. We are trying to solve those problems first, and then after that we shall probably come to the other things also. The cost can also be brought down by scaling up the manufacturing, because if you scale up manufacturing, the per unit cost always comes down. So that is one of the ways in which we can do it. But for that, we have to find ways in which we find it useful. Right now, it's a luxury. in many of the cases, let's say especially in electronics, a foldable display phone is a luxury, and OLED or a QLED is a luxury. So that's why fine, even if let's say these luxury items right now are expensive, that's okay. But when it comes down to, let's say, a real time issue or a uh, daily usage, then probably we'll see that the things will change, and we'll try to scale that down. What is the purpose of polymerase chain reaction after a recombinant DNA process is produced? Because it shall it, however, be multiplied after the insertion of the host cell? See, we just try to increase the possibility, because with just one gene or one recombinant DNA, it's almost impossible for you to get the positive result. Same goes for, let's say, just think of it in the context of any disease. Let's say a virus enters. If the number of viruses or the viral load is high, in case of COVID-19, we used to talk about the viral load. So if the viral load is higher, the chances of infection are higher. Viral load being low, chances of infection are low. Something similar goes in polymerase chain reaction as well. If the number of genes being inserted are higher, chances of success are also higher. So that's why there is a number that we try to achieve there as well. Carbon nanotubes are pure form of carbon. Yes, you can say that. Do we extract graphene from carbon material? Yes, we do. We extract it from graphite. How microplastics play a role in nanotechnology? No, they are not related to nanotechnology as such, but these are also very small plastic components which are having very similar effect to what a nanoparticle might have. So that's why I am drawing the similarities between the two. The bacteria and the virus used as vector or the carrier in recombinant DNA extracted from the host organism? No, 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 no. Because host organism could be a plant, no relation with the virus or the bacteria. So virus and bacteria will be chosen independently. Nanoparticles does accumulate in plants like in bioaccumulation in fish. Yes, it can so happen, but chances are very, very low. Quantum dots used in quantum computers? Not exactly. It's a different concept. We'll discuss about that as well. Is there a different time zone in space, and if yes, how does it work? Time zone is something that we have defined for our own sake, so that's why we can't count space there. The time zones that we have defined on the earth, it's for our uh, ease of understanding time or using time. Is the concept of time travel possible? Not yet practically. Let's see. How totipotent and pluripotent cells different? What are the specialized cells which cannot be formed from pluripotent? So basic difference between pluripotent and totipotent is that pluripotent, almost into every cell they can change into they can, I mean, grow into, but not the reproductive cells. The basic reproductive cells, they are possible from totipotent only. So that's why just after cell division, within the first two cycles after fertilization, when the cell division starts, that is where totipotent lies. And the reproductive cells can also be formed from there, which mostly we see that is not possible with the pluripotent cells. In various types of technology, even various types of diodes, we use aluminium or cadmium. Can we use other metals or non-metals in these type? Yes, we can use others, but aluminium largely, when it comes to any kind of metallic use or any kind of electrical use, aluminium, because it's more abundant and than many others, and it's also very cost effective. It's cheaper as compared to most of the other metals, and that becomes one of the reasons. It's also something that reacts very easily with others, so we see that we can use it. These examples are new. I have one of the old examples where Hanumanji uses nanotechnology. Yes, in a manner, you can actually say that. The way some of the incidences have been uh, uh, described in Ramayana, you can actually say that it is an interpretation of the same. Yes, absolutely. Right. So I've taken a lot of questions. So let's move forward. Now, first, let us just have a look at some of the questions that have come in the past from nanotechnology perspective. So first, if you see, what do you understand by nanotechnology and how is it helping in the health sector? So if you see this question, there are two parts to. Now when it comes to these kind of questions, there are chances that we skip a part of the question. That if you see, this clearly states, what do you understand by nanotechnology? This is the first question. And how is it helping in the health sector? So there are chances that we directly start writing on the health sector. We might directly start writing on the health sector without writing anything on nanotechnology. We might give a very brief introduction to nanotechnology and we write the entire answer on health sector. But that's not what we have to do here, because here clearly there are two parts to this question. First part is, what do you understand by nanotechnology? That's the first thing that they have asked you. So you will also have to spend some time on writing about nanotechnology. That will define what nanotechnology is. Then we'll talk about the various aspects of nanotechnology, some of the key features of nanotechnology that we discussed in the introduction part. So that should be given some space, that maybe 30 to 40 words should be given in writing about nanotechnology there. And then come to health sector. We discussed about 5 6 different points where in the health sector we can make the use of nanotechnology easily. So that's why you can very easily write 70 to 80 words in this part. And then lastly, when it comes to the conclusion, you talk about the future. You talk about these are the areas where potentially nanotechnology can be useful because of the properties that we see here and there. So that is where you can give a good ending to this kind of question. An easy question, direct question, right? Look at the second question, asked in 2016 paper. Why is nanotechnology one of the key technologies of the 21st century? That's the first question for you. Describe the salient features of Indian government's mission on nanoscience and technology and the scope of its application in the development process of the country. Second question. First question, why nanotechnology? This is what again we discussed in the introduction, that what nanotechnology can do, what nanoparticles can do, and what are potential things that we can do. As I described in the beginning, I told you that it's just around 10 to 20% of what we can achieve through nanotechnology, what we have achieved right now. So that's why there's a lot of scope into the going into the future. So that's the first part. Now this was asked for 200 words, so this part can be written in 40 to 50 words. This part you can write in 40 to 50 words. Just describe that. For example, we discussed that nanoscale is that scale where for the first time your matter starts to show some properties. Correct. The matter as it exists at our level, they start to show these properties first at the nanoscale. And also how we can manipulate the particles at nanoscale and how we can change their properties, the melting point example that I had given you. So all these things, you can take the carbon example, you can take the hydrogen oxygen example and illustrate how exactly all these things can be done. And then the second part is simply about the nanomission. We discussed the nanomission, we discussed the various aspects of nanomission, and you can talk about how in practical solutions we can make the use of nanotechnology and how it can help there. That how in various sectors it can increase our efficiency in one way or the other, or whether in case of energy savings, how exactly it can help. So these are the things that we can write. And while concluding this kind of an answer, see, because what we are talking about, we started from the present, we are going slightly into the future, because we are talking about the scope of its application in the development process of the country. So we are slightly going into the future. So that's why when you conclude, when it comes to the conclusion of this kind of an answer, largely it should be about the future. Largely it should be about the future of where we are headed and what we can do in the future with regards to nanotechnology. What else can we? All right, so these are things that we are doing, these are the things that government of India has been trying. This is what can be done in the future. So you have to go towards the future. Some of the key problems that we discussed, you can mention that in brief, and you can conclude that okay, these are the things that we are trying to overcome today. Don't end in a negative note, never end in a negative note. You talk about that okay, these are the issues that remain, but we are overcoming them, we will overcome them. And this is how you can basically conclude such an answer. All right, so that's why easy questions, right? Easy questions have been asked from here. Let's also look at biotechnology, what we had discussed yesterday. So biotechnology also, you'll find that the questions that have been asked are fairly simple. So first question, what are the research and developmental achievements in applied biotechnology? How will these achievements help to uplift the poorer sections of the society? So first, we are talking about applied biotechnology. So applied biotechnology is nothing but the practical applications of biotechnology. The entire chapter that we discussed was nothing but applied biotechnology, right? So what are the research and developmental achievements? So now this can be a very big answer, because I spent some three and a half hours just in explaining all these different achievements. So you have to just compress it down, because it's a 250-word answer. This part very easily can go up to 100 words. It can very easily go up to 100 words. And before that, there would have been a very brief introduction to biotechnology and how does it help in uplifting the poorer section of the society. So here again, you can talk about the solutions. So for example, how it has helped in agriculture. So in case of agriculture, how the farmers get the help, how they can increase their productivity, they can increase their income, they can produce better produce, and they can be secured in their sense. Then after that, you can also talk about how in medicine, in the medical field as well, we see that there is a lot of application and reduction in the prices of the treatments available, or let's say the drugs available, the vaccines available. There are so many things where we see that it can help and provide a better healthcare facility, and all these things also are related to that. So we can discuss about that. We can also discuss about the environment and how it can help in the decontamination of the environment, what we discussed as bioremediation. You can talk about that as well, so that health standards of people in general can also be improved. So there are all these things that we can also discuss. How also about your food, that how exactly we discussed about biofortification. So but that biofortification also, how it helps in uh, providing help to people who do not have access to all these kind of nutrients. So all these things can be mentioned here. Then next question, if you see, how can biotechnology help improve the living standards of farmers? It's nothing but everything that we discussed as agricultural applications. Just that you have to change your language. You have to change your language, because it has asked how does it help in improving the living standards of the farmers. So that's why you can talk about those applications that we discussed and link it to the farmer's life, link it to how the farmers can use it. So that's why your language will change, answer will remain the same of what we discussed in our chapter as well. Why is there so much activity in the field of biotechnology in our country? How has this activity benefited the field of biopharma? So why so much activity? You can simply talk about the potential of biotechnology, right? What can be done with biotechnology, and what we have been trying to do with biotechnology, and then biopharma. So in biopharma, you can discuss a lot of things that we discussed, that what is pharmacogenomics and pharmacokinetics, and what India is doing in the field of biopharma. You can talk about the generic drugs. We'll discuss about generic drugs later, but you can mention all these things in this kind of a question. And then look at this question, another simple question directly based on stem cell therapy. Stem cell therapy is gaining popularity in India to treat a wide variety of medical conditions, including leukemia, thalassemia, damaged cornea, and severe burns. Describe briefly what stem cell therapy is and what advantages it has over other treatments. So now, if you look at this particular question, this basically is about uh, how exactly stem cell therapy is important. And just look at this entire part, they are only praising stem cell therapy, right? They're only praising stem cell therapy. and they're not saying anything else, correct? They're not saying anything else. So uh, in these kind of questions also, one thing has to be remembered, that you see that it has a pretty positive tone, correct? This question has a pretty positive tone. They're not talking about what are the pros and cons, or what are the advantages and disadvantages of uh, stem cell therapy. They're simply saying that it is advantageous, look at how they can help. So you should also follow a positive tone in this kind of a question. You should also uh, follow a positive tone, because they have followed a positive tone. So, and it becomes very very useful, because we see that many a times this is uh, a mistake that many of us do while writing the answer, that we also start talking about that this is the limitation of stem cell therapy, this is going wrong, this is not this is costly. So you can, there are all these things that people start mentioning many a times. So that's why you have to understand that because it has a very positive tone, it has only talked about what is stem cell therapy and what are the advantages. So just talk about that, just talk about that. Even if you, let's say, mention a couple of negative points, mention them as briefly as possible, but again, talk about solutions to these problems instead of just talking about the problems. But as much as possible, because the question has a positive tone, you should also try to follow a positive tone, and you should have uh, uh, a very simple positive approach to writing this kind of an answer. Then one more question: what is allelopathy? Discuss its role in major cropping systems of irrigated agriculture, asked in 2016. Now this is a question, you can say, borderline between economy and science, because we are talking about agriculture, so it's also, you can say, partly on that science. Now when it comes to allelopathy, so allelopathy basically is where we see that, do you know what is allelopathy? Any idea what allelopathy means? Because this can also be one of the problems, that you don't even know that one what allelopathy is, and you might also get confused, as I see that some of you have gotten confused. Yes, Janvi, you are correct. So uh, allelopathy is not allopathy. Allopathy is the medicine form that some of you have mentioned here. Allopathy is different. Allelopathy is different. So allelopathy, what we see is that there are certain cases where a plant might release certain kind of chemicals that can affect everything else that is growing in its environment. So for example, let's say it releases certain chemicals that will not let others grow, which will not let others grow, or they might absorb so much of nutrients and so much of water from the soil that it hampers the growth of anything else in the surrounding. So then in that case, we say that it is allelopathy. So discuss its role in major cropping systems of irrigated agriculture is what has been asked. So now there are multiple ways in which we see that we can make the use of allelopathy. So for example, it can be used in weed suppression. It can be used in weed suppression, where you basically, what we'll be doing is that we'll be trying to suppress the growth of unwanted plants in the given area, when there will be some of these crops which will release the chemicals which will not let the others grow, or the weeds etc grow in that field. So that's why they can be used there. They can also be used in pest management as well. They can be used in, or pest control rather, let me write pest control. So they can be used in pest control also, because we see that many of these allelopathic compounds or chemicals that we have, they will inhibit the growth of the pests and other microorganisms. So that also can be done. Then we see that in crop rotation also, in crop rotation also, we can make the use of allelopathy, right? In crop rotation also we can make the use of allelopathy. So uh, that is also where we see that it can be used. Then apart from that, we also see that they can also help in influencing the nutrient cycle of the soil. All right, they also have an influence on the nutrient cycle. on the nutrient cycle of the soil, they can have a positive impact as well. That, for example, let's say there are some plants which can release nitrates into the soil. So then in that case, nitrates in the soil is basically the nutrition for the soil. It will also help the other plants grow. So they can also have a positive impact on the soil. uh, they can either, that's why they can also enhance the nutrients, they can also eat up the nutrients. Both can actually happen. And that's why we see that allopathy can be useful in all these cases. All right. So that's why, I mean, I'm explaining this because this is something that we have not discussed. This was more of kind of a current affairs question. So allelopathy is when we see that there are certain crops release chemicals that affect the growth of growth growth and development. It's growth and development of other plants in the surroundings. And this can be a positive or a negative effect. All right, it's not always negative, it can be a positive or a negative effect. So that is what allelopathy is. So these are the questions that have been asked in the past from these topics. So as you can see, most of the questions are easy. Yes, once in a while it does happen that a question like allelopathy will be asked, but that also was based on current affairs. So it's not that it was a completely alien kind of question that you don't know the answer to. If you were writing in 2015, you might have come across these topics from mostly from uh, the the side of economy. This was more of an economy question, although because biotechnology is involved, that's why I've taken this question here. So anyway, so moving forward, coming to the next topic of robotics. First and foremost, to talk about the prelims and the mains examination and the relevance of this particular chapter in prelims and mains, I would say that it is not relevant. Uh, in all the other chapters, I've been telling you important from prelims perspective or mains perspective. Here, I'll say not important from prelims and mains perspective, but we can't help it. It's a part of your syllabus. You have to read it. So, because if you look at the question papers, if you look at the past papers, even if I combine past 15 years of prelims examination, do you know how many questions have been asked past 15 years combined from robotics? The answer is zero. The answer is zero. None. And only one question in the mains examination. Past 15 years combined. One question in mains and zero question in prelims. And there is a reason for that. The reason is that India hasn't done a lot in robotics. In the last 30, 40 years of development of robotics across the world, we see that in India, we have hardly taken any step. Uh, the industries have not worked a lot. The governments have not worked a lot. Not a lot of money or not a lot of budget is provided. There is no policy with robotics. So that's why we have seen that robotics has been a topic that nobody wants to touch. Politically especially, none of the political parties would want to touch robotics because robotics always has been associated with the loss of jobs, and rightly so. It's not that it's a misplaced assumption. It's not a misplaced assumption. It is something that can happen with the introduction of robotics. So that's why politically no party would ever want to touch robotics, and that is what we have seen in the last 30, 40 odd years, that there are so many governments that have come one after the other. Nobody had a policy that supports robotics in any way or even talks about robotics in any way. So because the main factor being that everybody just has this notion, which is not completely wrong, that robotics, the introduction of robotics would mean that a lot of people will lose their jobs. So, a small chapter, but still there are certain perspectives from where, even if possible, there are certain areas from where questions can come. So, that is what we'll discuss in this particular chapter. Now, when it comes to robotics, first and foremost, let's try to understand what do we mean by robotics. So, robotics is you can see in a manner a sector of science and technology where we are talking about the use of mechanical robots, the use of mechanical robots, the design, construction, and use of mechanical robots in various different fields. Now, what do we mean by a robot? So, robot in general, when you imagine a robot, you think of a walking and talking machine, right? If you have seen Robot or the Robot 2.0, the two films starring Rajnikant, then you might know what robot looks like, correct? And there are so many films in English as well, in Hollywood, that have been made on robots. So, we have a fair idea of what robots are. In general, when we think of a robot, we think of a humanoid form that can walk and talk and do some work for us. But it's not always the case, right? It's not always the case that a robot should look like a human. There's no such there's no such concept of it always being a human form. So robot in general could be any machine that can take input and can do a work based on that input, can do a mechanical work on its own based on the input provided to it. So any such machine can be called as a robot. Now, when it comes to the use of robots, the very first thing that we need to understand are the three laws of robotics that were given by Isaac Asimov. Now, Isaac Asimov also has been a very interesting character. He was not at all related to the field of robotics. He was more related to biochemistry, but he has been somebody who has written a lot of science articles and a lot of science fiction articles as well. More than, I think, 500 publications in his name. There are many books also. You go to Amazon or Flipkart, you type Isaac Asimov, you'll find a list of books that he has published in various different fields. So he actually had suggested three laws of robotics because robotics was something that was growing, and that's why he had suggested that these three things should be followed if you are manufacturing robots, if you are using robots in any way. So what are these three? First law says a robot may not injure a human being or through inaction allow a human being to come to harm. So neither a robot is allowed to injure a human being, nor it should allow something to happen on a human. Even if something is happening to the human, it should protect the human. So very first thing. Second, must obey the orders given to it by human beings, except when such orders would conflict with the first law. That any order that has been given to the robot has to follow the order. But if that order is to attack another human being, then the order should not be followed by the robot. That's the second law that he suggested. The third law is that a robot must protect its own existence as long as such protection does not conflict with the first or the second law. That robots can protect themselves, they must always protect their existence, but not at the cost of a human, not at the cost of a human life. So that is basically what these three laws of robotics basically talk about. So more than laws, you can say that these are more like guidelines, right? These are more like guidelines that he had suggested, that manufacturing of robots, wherever it happens, these should be adhered to so that you do not cause any harm to any human. So how do we define a robot? So in general, if you look at this is how we can look at a typical robot. So you may not like this, but this is what a robot is. So it's that's why I said that it's not always necessary that it must have a human form. So when we look at a robot, there are few components of any robotic machine that become very very essential to its very existence. First is a controller. First is a controller. Now controller, you can say in a manner, is like the brain of the robot. We can say that it's like the brain of the robot. Now, why I'm saying that it's like the brain of the robot? The reason is that the reason, what does the brain do? Brain gets the information, it gets information from all across the body, from all the cells, all the nerves, etc., and it takes a decision based on all the inputs that it has received, correct? Based on the inputs, it will do various different kinds of work. It controls and coordinates for all the activities that we perform voluntary or involuntarily, right? So same goes for the controller as well, that everything that a robot needs to do, every activity will be controlled and coordinated by the controller. So it's like the microprocessor or the microcontroller that we have on our mobile phones or laptops, etc., where there will be a central processing unit that will do all the work. that will take all the decisions, where you give all the inputs and it gives you the output. Similarly, you have a controller here as well, which will take all the decisions based on the information provided by the sensors. So sensors basically will be, you can say, the eyes and ears of the robot. So sensors are like, in a manner you can say that these are like the sense organs. Can you name me the sense organs that we have in our body? Quickly, somebody. Can you name me all the sense organs, please? Yes, eyes, ears, nose, skin, tongue. Correct. So everyone was giving one answer. Chatni, you've given the correct answer. Abhishek, you are also correct. So eyes, ears, nose, tongue, and skin. These are the five organs which are called as sense organs. Why are they called as the sense organs? Because they are connected to the outside world, right? They are connected to the outside world. So whatever is happening around us, they are the ones who would understand that these are the things that are happening in the outside world, and they would pass on this information to the brain, and the brain would take a decision based on what the brain has received as information. So whatever you see, whatever you hear, whatever you taste, whatever you feel, all these kind of things, uh, 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 we see that all these are sense organs because they are connected to the outside world, and they pass on the information to the brain takes a decision based on that. So something similar happens here, that the sensors will collect that information, send the input to the controller, and controller will take a decision based on it. Then we have the actuators. Now these actuators, they are also called as the muscles of the robot. We say that these are like the muscles of the robot. Now why we say that these are muscles of robots? The reason is that, what does the muscle do? Okay, next question. What is the role of muscles in our body? Okay, movement, connecting tissues. Okay, helps in motion. Yes, rhythmic motion. Yeah, you can say so. Strength, that's also correct. Protect the bones. Yes. Makes one capable of doing something. Exactly correct. Yes. So basically, the muscles that we have in our body, they would help in motion, they would help in any kind of mechanical work, right? They'll help in some kind of mechanical work. So they are related to conversion of energy into movement, conversion of energy into mechanical work. So whatever we eat, whatever carbohydrates and fats we accumulate, that will be converted into energy, and that energy will be used for some kind of motion, voluntary or involuntary, with the help of muscles. So that's what muscles do, that they would convert energy into mechanical movement. Same happens with actuators. So they also are receiving energy from batteries, that there will be batteries or maybe electrical power supply that is running this robot. So that electrical energy or the battery power that they are receiving, they would convert this energy into mechanical movement. That's the role of the actuator, and that's why we are saying that this is like the muscle of the robot. Then we have the manipulator. You can say that these are like the arms of the robot. These are like the arms of the robot, just like how we have the arms, they also will have these arms, which will help in the movement of things. For example, picking something, placing something from one place to another. In all these cases, you would have these kind of mechanical arms called as manipulators. And then lastly, you have the end effector. So end effector, you can say that end effector is like the hand of the robot. So that's why end effector are like the hands, that you can pick something, place something, whatever you want to do with the help of robot, all that can be done with the end effector. So that's why these are five important parts of any given robot, any mechanical robot that we are defining. These are the ones that can be called as the parts of the robot. So just to summarize what we discussed, you have the controller, coordinates all the movements of the mechanical system. That's why we are saying that these are like the brain of the robot. Then after that, you have actuators, as we discussed, that these are like the muscles of the robot, converts the stored energy into movement, right? Then after that, We have the manipulators, which are like the arms of the robot, and they are the ones which will help in moving the materials, parts, tools, or special devices through various motions to provide useful work. Then after that, we have the end effector, which are like the hands. So where we see that they will help in grasping or lifting, transporting, maneuvering, performing operations on a workpiece, etc. Then after that, we have the sensors. So sensors, they will be used as a guide to the robot. That's why we are saying that they are like the sense organs. They're like the sense organs where they would gather the information about the environment. Then the power source. Power source would be any kind of batteries. There could be different types of batteries that could be used as a power source in this particular robot. So these together they become various components of this robotic system, right? Now, when it comes to the robot, we understand that there are various different applications of robots. So when we look at these applications, for example, let's say military applications. So in military applications, it can be used in various different ways. For example, it can be used in search and rescue operations, in transportation, or even attacking the enemy. But when you attack the enemy, you are violating the law that was given by Isaac Asimov. But if you don't care, you don't care. If you want to make a robotic army, you would do that without thinking about what Isaac Asimov has suggested. This, for example, do you know the name? This is an Indian robot made by DRDO called as Daksh. So Daksh basically is a search and rescue robot. All right. So in military applications, it can be used. In industrial applications, it can be used. So various different things like welding or assembly, picking and placing things, painting, packaging, labeling, product inspection, testing, all these kind of activities in the industries, they can be automated and they can be done with the help of robots. So for example, this that you see, this is a robotic arm, which is very famous and it is called as Skara. In the industries, this is very often used. This is the Skara robot, which is more of a robotic arm. You can say that this is like a robotic arm. Similarly, in agriculture applications also, there are various different ways where in agriculture also we can make the use of robots. So for example, let's say in even plowing the field, we see that we can actually make the use of robotic systems here. But again, when we look at something like this in India, we see that in agriculture we haven't been using robotics at all. We still haven't used it. And again, I mean, obviously there is a big fear, because once you start automating all these things, yes, you perhaps will increase the productivity, but at the same time a huge number of people are going to go out of jobs, because agricultural laborer is being one of the major sectors in the unorganized sector, especially where we see that they all find their daily wages, they find their money to survive. But all these can completely be changed if, let's say, robotics is introduced in agriculture. So that's why we see that more or less agriculture has been kept aside and robotics hasn't been introduced there. Then in medical science, now in medicine also we see that there are various different types of robots that can actually be used. Majority of it, what we see is that there are surgical robots where a lot of emphasis today is being put, that in case of precision surgery, the surgeries that can go for very long and they can be very tiring, we see that to increase the precision in these kind of things, we see that robots can actually be used there. So surgical robots, they actually have been becoming very popular, and we see that hospitals across the world, they have been using these kind of robots. Then after that, we also have nanobots. What we discussed, that with the help of carbon nanotubes or with the help of silver or gold nanoparticles, we want to do the drug delivery. So that drug delivery being done with the help of nanoparticles is nothing but a nanobot. It will be called as a nanorobot or a nanobot. So that's why carbon nanotubes can be taken as examples, or gold nanoparticles can be taken as examples. So all these are particles that can be called as nanobots or nanorobots. The 2016 Nobel Prize, 2016 Nobel Prize in Chemistry was given for design and development of molecular machines. So these molecular machines, they are nothing but nanobots. In simple terms, these are the ones that can be called as nanorobots. Then, in outer space applications as well, do you recognize this robot? Anyone who can tell me has been in the news? Many of you are writing Sophia, but it's not Sophia. Yes, Sakib, you are correct. Akansha, you are correct. Aniket, you are correct. This is our very own Vyom Mitra. So Vyom Mitra is the robot that we are going to send as a part of the Gaganyaan mission. Right? As a part of the Gaganyaan mission, we are going to send Vyom Mitra. Now, in this particular case of Vyom Mitra, this is the first time that ISRO would be using a robot for a space mission. And this also opens up an arena for us for the future, that let's say when we are going into a mission that can be unsafe for humans, or let's say an outer space mission, you cannot send a human into an outer space mission. You have to bring them back as well. So that's why instead of using humans there, you perhaps will want to send a robot. So that's why these kind of robotic systems that we now are venturing into can be a very good indicator of what we want to do in the future. So that's why in outer space applications as well, we do see that we can make the use of robots here. So that's why there are multiple different ways in which robots can be used. And that's why there are multiple applications in the industries, in medical field, in defense and outer space, and everywhere we see that robots can actually become useful. But then there are challenges that we see in India today. There are problems because of which the growth of robotics has not happened. First, a lack of hardware ecosystem. That if we want to increase the productivity, if we want to increase the manufacturing of robots, we also need to have those materials ready for us. We need to have that hardware ecosystem so that manufacturing of robots in India can be scaled up. So that's not there. Then after that, we have the financial, we do not have any kind of financial incentive as well, where we see that there is no financial support that has been provided by the government of India ever if you are working in the field of robotics. That let's say if an industry or maybe a company wants to use robots, it is not being encouraged at all. And it's not that you are going to get tax concessions for doing that and all these things. So that also has been a problem. And then the lack of required knowledge, because we do not see that there is an academic support to robotics, right? There's no academic support that is being provided, and that also is a big challenge, because robotics will be studied only by people who are specialized in certain branches of engineering. Let's say mechanical engineering, electronic engineering, server engineering, computer science engineering. These are people who would somehow get in touch with robotics, and that too in a very limited way. But in the school level there's nothing. Until class 10th there is nothing. Even in for the people among you who would have taken science in class 11th or 12th, you never hear about robotics, right? So until class 12th it's completely absent. So unless somebody already knows about robotics and is self motivated to go to the field of robotics, you have no idea about what robotics is. So that kind of a support also is missing, and that also leads to us not having that kind of uh, human resource pool that can help in robotics in India. So that's why you have to identify that if we want to build a future with robotics, if we want to scale up robotics, if we want to, let's say, scale up of up our industry so that they can use robotics for better manufacturing, better productivity, etc., there are certain things that we'll have to do. That first and foremost, we have to identify the first wave technology. Now when we say first wave technology, First wave means where do you need to start from, where do you want to start from. So for example, let's say if we consider a smartphone. A smartphone was not always a smartphone, it was a mobile phone, right? So mobile phone, what was the basic purpose of a mobile phone? That it should help you in uh, establishing a conversation even if you are outside somewhere. You don't have to sit beside your telephone all day long. Even if you are outside somewhere, you can still talk to people who you want to. So that was the whole purpose, right? This is where it started from. Today, of course, the mobile phone has a completely different meaning, but this is where it started from. So you can say that in a manner, for the mobile phone, this was the first wave technology. Similarly, for robotics also, we have to find out, or we have to identify the sector where we want to begin from. So for example, let's say it could be defense, that we want to begin from defense. We want to first implement it in defense and then perhaps move to other areas. So that is why identification is required, because defense, for example, let's say, is a safe zone. No jobs will be lost. There's no problem that it will have on public in general, and yet it will have a lot of advantages. So that's why it becomes a good sector to start from. Then optimization of resources. Every hardware resource, every human resource that we have to optimize the resources so that it does not become a very costly affair, it does not become very expensive for us. Improving the productivity also is a part of the same, that we'll have to have a better productivity, and it will also help us in having a better productivity everywhere wherever we are making the use of these robots. Then using more of industrial robots, especially when it comes to the automation, that wherever there is a possibility that automation will be able to increase our productivity, we can make the use of industrial robots there as well. Then providing an academic support, as I told you, that this is something that has been missing from our curriculums at the school levels. So that kind of academic support is required. Maybe scholarships to the people who are doing well, who are doing the research. That kind of research grant can be given to these kind of people. So that academic support is also required, uh, so that they can do something there. Deep specialization in server engineering, electrical, embedded programming, and mechanical engineering is also required. So until now, we see that unless somebody really wants and is really specialized, they don't have a working knowledge of robotics in India. So that also needs to change, especially for the engineers who are already in that field. And then ensuring the safety and the quality of the products, that also becomes very very crucial if you want to generate some interest and enthusiasm in the tech field with regards to robotics. So there are all these steps that we should take. These are the steps that if we take, we might see a growth in robotics. But as of today, we do not really see that there is something that the government has been focusing on, or there is any kind of development that has happened in these kind of fields. So these are the kinds of questions that can directly come in your paper as well, that what are the applications, what are the concerns, what is the future, what are the problems. So in this manner they can actually ask questions, because above this level it's completely engineering, and which is not really required for your examination. So a small chapter, but yes, I mean there are chances that questions can come from here as well. Any question? uh, Anyone, any question? If you have, please let me know. Academic support like targeted scholarships for research and focus on STEM education. Yes, of course, that is basically what I was referring to. That if you have these kind of support systems, financial mechanisms available, it will always help in the growth. Please explain the first wave technology in optimization of resources in the future of robotics. So when we are saying first wave technology, the meaning of first wave technology is that this is where you want to begin from. All right, this is where you want to begin from. So that will be called as the first wave technology. So as I gave you the example of the mobile phone, so mobile phone is an example of how exactly we began. That mobile phone first exactly was just for you to communicate while you are outside. But then we see a lot of improvements happening, that SMSs could be sent, and camera was added, and internet was happened and added, and today it's a completely different story. But started from there. So similarly, in case of robotics also, before you look at all the sectors, and this is also where we can use it, there also we can use it and all that, first start from the basics. First start from where it actually can begin from. So that's why I said that one of the suggested areas could be defense, where we could actually start from. Sophia basically is a robot which got its name after the human-like appearance that it has, and the kind of simple conversations that it can do with a person, because of which it actually became famous. Optimization of resources also, right? So optimization of resources is for every hardware and software resources that we have, and how we can use it for a cost-effective production of robot in the manufacturing. Any space agency has said sent robots in space. Yes, NASA already has done it. So for example, uh, the rover that you have, the Mars rover, the Curiosity rover that you have, you can say that in a manner it's a robotic system. Difference between working of robots and AI, we are just going to discuss this. Hmm. Gaganyaan isn't sending humans into space. Yes, it is sending humans into space also, but a robot also will be a companion to the people who are going on board. So two people most likely, and plus one robot. Can we call laptops, mobile phones as robots, as they don't have all components? So no, we can't call them as robots, because these are systems which are not doing any mechanical work, right? The laptop or mobile phone does not go somewhere, and it's not been programmed to do the work on its own. You are controlling each and every activity. Whereas in case of a robot, you do not control each and every activity. You do not, even if let's say, then you might ask me that is a car not a robot? It's not, because you're controlling each and every activity. It's not acting on itself without you having to control it each and every second. So that's why those systems are mechanical systems, but not robotic systems. Robotic systems will be where there are sensors, and these sensors are sensing the environment and doing their job on their own. They are making the movements, etc., or the mechanical work on their own, right? So let's move on. A small, I mean, we'll not be able to finish this chapter, of course. Small introduction to what artificial intelligence is. So we'll begin with the first part, and then we'll continue in the next class. So when we say artificial intelligence, what is the meaning of artificial intelligence? First and foremost, from the perspective of your examination, it's a very, very new topic, not even mentioned in your syllabus, but of course, we are expecting that questions will come from here. So there is one question that they have asked in the prelims examination, 2019, or 2020, 2019, I believe. They have asked one question already. Means until now they have not asked a question, but there's a lot of scope. There's a lot of scope that the questions could come both in prelims and the mains examination from artificial intelligence. Now, in case of artificial intelligence, so first and very first thing that we need to understand is what do we mean by artificial intelligence. So today we know that there are n number of examples where we are saying that artificial intelligence is working, but how do we define what artificial intelligence is? First thing, when it comes to artificial intelligence, two words: artificial intelligence. So intelligence is something that is related to cognitive abilities, you can say, the ability to think, to perceive, to make decisions, to solve problems. So all these things, to act on something, to comprehend something, to so all these things can be said to be intelligence. So intelligence does not mean that somebody should be good in studies. So that's not always intelligence. Intelligence can be of various different forms. Intelligence wherever you have a good level of cognitive ability in any way, right? In any of the ways. So that's why I'm saying that thinking abilities, perceiving, acting on something, problem solving, decision making. All these things are attributes of human cognizance, and that's why these kind of cognitive abilities can be called as intelligence. And when we can impart all these things into a machine, it will be called as artificial intelligence. All right. So that's why when we talk about artificial intelligence, this is how we can define it. Refers to the ability of machines to perform cognitive tasks like thinking, perceiving, learning, problem solving, and decision making. So that is basically what we are saying when we define artificial intelligence. Another way to put things could be that it is the technology that enables the machines to act with higher levels of intelligence and emulate the human capabilities of sense, comprehend, and act. So that's why when we are talking about all these things, or the abilities of learning and problem solving in machines, then in that case we are saying that it is artificial intelligence. Now today what we see is that artificial intelligence is making its wave everywhere. From the biggest of the things to the smallest of the parts of our life, we see that artificial intelligence is working. So for example, let's say if you talk about image processing, there are satellites that we discussed, that there are satellites in the low earth orbit that keep sending pictures and videos all day long, every second. So there are so many pictures, so many videos being sent every second. We need something to process them, and that image processing today we see that can be done with the help of artificial intelligence. A kind of pattern recognition can be done with the help of artificial intelligence. It can give you results faster. It can predict the future faster. I mean, future of the weather, etc. I'm saying. So all these things can be done with the help of artificial intelligence much faster. Even let's say any set of pictures and videos that we have received with regards to disaster management, the processing of those images, understanding those images, potentially what can be done and what should be done, all these kind of things can also be explained by, can also be done by the artificial intelligence. Then similarly we see that energy optimization city wise or in industries can be done. Traffic management can be done. Infrastructure understanding can be done. In genetics it can help you, understanding of the genetics it can help you. So the biggest of the things in the medical field, etc., can be can use artificial intelligence, has been using artificial intelligence. From there to the smallest part of our lives, probably every app that is there in your mobile phone is today using artificial intelligence to get the idea of the customer, to understand what the customer is and what the customer needs, and accordingly they are doing everything. And every decision, you'll see that at least for the bigger companies, every decision that they are taking, that decision is based on the inputs of artificial intelligence in one way or the other. So for example, let's say if I ask you, why do you think that Instagram has reels or YouTube has YouTube shorts? The reason is simple, that they see the world changing. They see the world changing, and how first TikTok became so famous, so popular, that they also thought that they need to do something similar that can do everything that these are doing. So that's why they came out with Instagram reels and they came out with the YouTube shorts, because they also understand that the retention uh, the retention capabilities of people today are not that great. They're not as good as they used to be. So they also have to change with time, otherwise they'll become obsolete if they don't change with time. So they know now that humans do not have the capacity anymore to sit through something and just sit there for an hour or maybe 2 hours and just learn something. Instead, we want a 1 minute video, we want a 30-second video that can do everything for us, that can tell us. I mean, for example, if instead of sitting through and having to manage your 3.5 hours of this these excruciating lectures, if I could tell you what artificial intelligence is in 30 seconds, you'd probably prefer that instead of just having to sit here since 6 a.m. in the morning, right? So we have seen that all these things have been changing. The retention abilities of information of people have been reducing, and that is where we see that everybody also has been changing. Even for example, let's say your tablet lectures, the tablet lectures today are smaller bunches, are divided into a smaller bunch of lectures, every subtopic just being 10-15 minutes and so on. The same lectures 6-7 years back used to be one big chapter. Used to be, for example, a chapter like, let's say, uh, fundamental rights, which is a big chapter, right? So it was one single chapter which is explaining everything in 7 8 hours. And now what have we done? That chapter has been divided into very small chunks: article 14, article 15, article 15 clauses, and so on. Why? Because we also see the changes in the students, that how, if we today give an 8 hour lecture or an 8 hour chapter, chances are people will leave it. One of the reasons how recordings work, that you have the recordings, and if, especially if you are from a weekend batch, probably you will not sit through the entire day, watch some parts and watch the recordings of other parts. So we see that this is something that has been happening here, that unless you are motivated enough, that you are preparing for UPSC, you know that you have to sit through a 3.5 hour lecture, then only you do that. For others, it probably will be surprising that when, obviously, I mean, you talk to your friends who are not at all related to your this kind of preparation, they'll be surprised that you sit through 3.5 hours of lectures. When I tell my friends that I am going to take a class at 6 a.m. till 9:30 a.m., they are also shocked, and they would ask me, does anyone even come at 6 a.m. in the morning to learn science? I say yes, they are motivated enough to come and sit through these lectures. So we see the world changing, we see these things changing very rapidly, and that is where AI has been adapting. That is where the analytics that they are getting with the help of artificial intelligence helps them to understand what the product requirements are, and they would make something accordingly. Even in advertisements you would see this, right? You'll see that the analytics are working there. You just go and search for something on Google, and you'll see that, or let's say for example, you go to Amazon or Flipkart, you search for something that you want to buy. uh, but then you come back, you think that, okay, fine, I don't need it, I'll not buy it. So but after that, you keep going everywhere, you go to Google, you'll see that advertisements of similar products will be shown there. You go to Instagram, you'll see that between the reels you'll get the advertisements of those things. So so now the entire world of artificial intelligence will be after your life, ensuring that you go and buy what you left, and you did not buy it. So all these things will happen. We see that these kind of targeted marketing is also happening in all these kind of cases, right? And forget about you just getting some suggestions here and there. I'll give you an example. I was in Chennai taking the offline batch of science and technology, this is last year. And there, of course, how I'm doing today or in these lectures, I would have used the term solar energy a lot of times in the classroom, right? And 2 days later, I get a call, and on the call, the lady on the other side of the call asked me, sir, are you looking for a solar energy installation, a new solar energy connection for your home? So it's not only about the suggestions that you get uh, the Google, or let's say on social media platform. The things have changed in a manner that now you're also getting the calls. And why the calls? Because your mobile phone is listening. The mobile phone or any electronic device with a microphone is listening to everything that you are doing all day long. So even if you want to buy something, you just keep talking about it all day long, the mobile phone will pick it up, and it will start showing you the results, it will start showing you the advertisements from that perspective. So that's why from the biggest to the smallest part of our life, we see that everywhere artificial intelligence is working today, right? So when we talk about this artificial intelligence, we'll understand some of the basics of what this artificial intelligence is and how it works, and then we shall stop the session today. So there are two basic concepts of machine learning and deep learning that work behind the scenes in making artificial intelligence work. And apart from that, there is another concept called as neural network. Neural network. These are the things that work behind the scenes in uh, making anything with regards to artificial intelligence. So first, what is machine learning? So when we say machine learning, it means that the machine is learning. All right, the machine is learning. So that's why we are saying that this is the ability of the machine to learn without explicitly being programmed. So a normal software is where everything has been programmed and the software does the work according to the programs or the instructions that has been fed to it. Whereas when it comes to machine learning, you will be training the machine. All right, you will be training the machine so that they can work on your own, they can work on their own. It's just like how I'll give you certain points in the entire chapter, but when you write an answer, you write on your own with the training that has been provided to you, or you solve the MCQs on your own based on the training that has been provided to you. Something similar is being done with the machines, that the machines are being trained with data and algorithms in a manner that they can do the work on their own. So for example, let's say a normal software based on calculator, where you type 2 plus 2 equal to, and it gives you a result 4, because it has been fed with instructions to how to add two numbers. So that's why when you write 2 plus 2 equal to, when you type, press the buttons of 2 plus 2 equal to, you'll get the answer 4. But then, let's say if the same calculator is based on machine learning, then what do? You keep feeding it the data so that it can understand the patterns and it can recognize those patterns. So let's say you have entered 2 plus 2 equal to 50 times on a calculator which is based on machine learning. So you did that 50 times or maybe 100 times. So when you have done this 100 times, the machine now has gotten trained with this kind of data. So now what happens in the future is that as soon as you start typing 2 plus, it might suggest you that the next thing that you want to type is 2 plus 2 equal to dot dot. So the machine now recognizes that this is a weird person who likes to type 2 plus 2 equal to all the time. So it also starts suggesting you in this particular manner. So this is a machine learning based system. You might have seen this with, let's say, you do a simple Google search. So when you do the Google search, you'll see that as soon as you start typing, the most popular results will start showing up in the scroll. Correct? It will start showing there. Even if you are, let's say, using Gmail today or any email services, you'll see that as soon as you start typing the email, it will start suggesting you based on what you have started writing. So as soon as you start writing the first part of the phrase, the second part of the sentence, they would try to auto complete for you, right? So something similar is something that we start seeing today, and all this is thanks to machine learning. All these are things which are thanks to machine learning, because that Gmail is also getting trained with millions of email users, or rather the Gmail users all across the world. So it has recognized how the set of words are being used by somebody. So that's why as soon as you start typing something which is something which is commonly used by a lot of people, you will see that autocomplete options will start coming. So all these are machine learning. All of these are machine learning. So that's why what we are doing is that instead of hand coding, if you look at this line, this perfectly explains what we just discussed. Instead of hand coding software libraries with well defined specific instructions for a particular task, the machine gets trained. The machine gets trained using a large amount of data and algorithm, and in turn gains the capability to perform specific tasks. Correct? So this is what we are doing. So instead of hand holding, we are training them. All right. This is what we are doing in machine learning. And then you have deep learning. Deep learning, that is not different, but a better or highly specialized form of machine learning. All right. So in case of, so that's why we are saying that this is a type of machine learning that can process a wider range of data resources, requires less data pre-processing by humans, and can often produce more accurate results than traditional machine learning approaches. So that's why compared to traditional machine learning approaches, we see that they can get the results faster, they can get you more accurate results, they do not need as much training as machine learning systems do. So that is what deep learning is, which is a better specialization, which is a deep specialization of machine learning. And one of the ways in which this deep learning works is with the help of something called as a neural network, right? Something which is called as the neural network. And with the help of the neural network, we see that we are training the machines much better, much faster, with very less amount of data as compared to what we were doing in case of machine learning. So in all these cases, that's why we see that it has really helped in making these systems much more refined than what they used to be. So that's why in case of deep learning, we see that it works with the help of these data and algorithm that we get from neural network. So a neural network typically works like this. A neural network typically works like this. So in case of a neural network, what we see is that there are inputs that are given to the machine, and there is an output that the machine will give. Between that, there are a bunch of hidden layers. Between this, there are a bunch of hidden layers, and all these hidden layers is where the data processing is happening. This is where the data processing is happening based on all the inputs that has been provided to that system. So that's why it is called as neural network, because these are like the neurons. And what does the neuron do in our body? Neurons will pass on the information, right? They would exchange the information from various parts of the body to the brain, and from the brain to the various parts of the body. Something similar is happening here, that the machine is also getting the input. It will process all this input based on all the hidden layers that they have, and ultimately an output will be given based on all these things that we see here. So that is how we see that this neural network works, and it helps deep learning in becoming a better version of machine learning systems, right? So this is basically how these things work. So for today, let's stop here. We'll discuss about what is weak artificial intelligence, strong artificial intelligence, and all these different types of artificial intelligence in when we come back in the next class. So tomorrow will be an off. On the occasion of Janmashtami, tomorrow we don't have a class. I'm sure that you all know that already. So next class that we have will be on Friday. I also have an announcement for you. Just remember the next classes that we have. First, we have a class on Friday. We also will have an extra class on Saturday, and then we'll have a class on Monday. These are the last three classes that we are left with. And then after that, on Tuesday, there will be a special class that we are conducting, and this will be a doubt clearing session. This will be a doubt clearing session where everything that we have discussed, all the things that we have discussed, you can ask anything. Every kind of doubt that you have, you can bring in those doubts. You can ask those doubts, and you can send us an email beforehand, so that I'll also know what are the doubts that I need to cover. So you can send your emails on islive@byju's.com. You can use, let's say, you can use uh, the heading doubt science and tech, something like this, and you can send in your email, so that we'll be prepared. We'll also be better prepared for you. And Tuesday will be completely on these kind of doubts that we have. So timings will be similar. Timings will be the same that we have every day. 6 o'clock in the morning, we'll take all these classes. Tomorrow is an off. Tomorrow there is no class. Please go back, revise everything. If you have anything that you don't understand, bring them back, but try to consolidate everything that we have been studying. So any doubt if you have, please let me know. Any doubt if you have, and then after that we shall end the class for today. What is the restriction enzyme? How does it actually help in our DNA? So restriction enzyme is just an enzyme that we have recognized the properties of, where we see that they will be able to make us make the cut at the required location uh, in the given vector or the carrier. Abhishek, you're concerned about the books. I'll check with the team if you have already sent it. Webinars for tomorrow, I'm not sure whether webinars are there tomorrow. I almost am sure that we don't have the webinars tomorrow, but still it's better if you can check with the support team, please. Timings every day will be the same. Timings every day will be the same. That will have the timings from 6 o'clock in the morning. The leaderboard, some of you have asked, this is the leaderboard for the day. We are keeping the class on Saturday also at 6 a.m. mainly because of the fact that there are some of the students who basically also uh, join us for the weekend batches as well. So that's why it's not convenient for them if we conduct the classes later. So this is the leaderboard. Yeah, the doubt session is for science and technology. Doubt session will be of science and technology only until Tuesday. Everything is related to science and technology only. History faculty Rohit sir looks similar to you. Yeah. So actually, in the office also many people have said this. Isn't machine learning and deep learning breach of privacy? They can potentially, yes, and that is where we have to ensure that it does not become so. And we'll discuss about those aspects in the next class. Did you check the mistakes of Saturday's objective? Oh, sorry, I completely forgot about this. I'll do this. I'll do this today. I'll check with them. Machine learning, just understand in simple words, machine learning is nothing but where we see that machine can be trained to do a certain task instead of programming that machine, where we are training the machine to do a certain task. Remembering the concept of biotech is very difficult. Try to first start to break it down from definition point, that definition wise these are the things that we have, and then the application. So then move on to the applications that we have discussed. So it will become easier for you from that perspective then. Is it because we use an external virus or bacteria to induce a recombinant DNA? There would be a challenge from the internal immune system of an organism. Yes, there will be, and that's why we see that there are chances that a lot of it will be also destroyed by the immune system. So we have to ensure that we have extra there. S- Space policy yet to be posted. Yes, I found that there were some issues, but today that is being solved, and today sometime it will be available for every one of you. Neural network is just a network of various different, you can say, stages of hidden layers where all the data processing is done with the all the input that is provided to the system, and an output will be given based on that. Why are countries facing issues related to solar energy absorbed through solar? I'm not sure about the context of this question. If you can tell me the context, I can understand it better. Can we say AI and robotics are closely related? Yes, of course, they are closely related, but completely distinct fields, as you have mentioned, Rahul. That's correct. Can you please keep the doubt class far later because we can revise properly regarding all topics of science and technology? I'll check. I'll check if something like this is possible for us to do. What does unorganized organism mean? Unorganized animals or organisms, basically what it means is that there are organisms which do not have a well defined nucleus, and everything that should be inside the nucleus, it's just distributed all across the cell. So those kind of organisms which do not have a well defined nuclear membrane, so that they can keep all the nuclear materials inside that nuclear membrane or inside the nucleus, they are called as unorganized organisms. How Voyager is able to travel so deep in space? It is taking uh, ac- it is taking, first of all, it has taken nuclear fuel along with it, and also it is taking assistance from the gravitation of various planets. So there is something called as gravitational slingshot. So it takes the help of gravitational slingshot and it keeps on moving towards the outer space. Emails, I have received emails, Ambika, as you mentioned, I've received emails from many of you. I could not reply to them because of the classes. Today, I'll have some time to look into all those things. Should we read NCRTs compulsory for science and technology? Not compulsory from the perspective of examination. It's not that questions come directly there, but it helps you in understanding a lot of things better. So from that perspective, it's good if you can read. All right, that's it. I think we have discussed the questions that you had. Where are you from? The short answer is India. Long answer is Ranchi in Jharkhand. Why are countries unable to store energy captured by solar energy? So basically, it's more about the technology that we still haven't reached, and a stage where we have those areas well defined that we can store energy better. So that is something that we have been trying, and we have been trying to improve there as well. So over a period of time we shall see an improvement there. In India also, for example, we have seen the improvement just in the last 10 years, and how our solar panels, etc., are much more efficient compared to what they used to be. So that's why we see that in all these cases they are uh, doing a better job, and of course they'll start doing much better job. Also, for many of these countries, they are in the temperate zone. So in the temperate zone, that solar intensity is not that great as compared to what we have here in our country. So that's why we see that there are all these cases of they not being as good, right? So let's end the session here. Thank you very much for being here. Please go back, revise everything, bring back the doubts, whatever you have, and we shall have a discussion on them in the next class. Thank you.